Okay, good morning, everyone. Good morning. Venkatramana, yesterday very neatly I have written the statement. Every discrete signal is not sample version of continuous signal. I have given an example like temperature versus time, cricket match, number of runs scored in every over. But again, you are stating like that. Every discrete signal need not be sample form of continuous signal. We can have predefined discrete signals also. We can have predefined discrete signals. Okay, let us continue our discussion. Yesterday, we started the basics of the subject. Definition of signal is which contains information. The properties, randomness. If randomness increases, information content increases. We can vary more than one independent variable. Third characteristic, bandwidth. Then we discussed some of the properties, some of the standard signals. What are the properties of continuous impulse we considered? Area under unit impulse is 1. Scaling property, del of alpha t we selected as 1 by mod alpha times del t. What about the product property? Xt into del of t minus t naught equals to x of t naught into del of t minus t naught. Sampling or shifting is what? Integral xt into del of t minus t naught is x of t naught. Shift should lie within the limits. Which are the singularity functions we studied? Singularity functions are the functions which are not having higher order derivatives. Higher derivatives, examples like ramp and step function. The functions which are not having higher derivatives are taken as singularity functions. So let us continue our discussion. Everyone try to draw the signal graph. If we are adding 3 step functions, how the resultant graph will appear? Sum of 3 step functions are given. How the resultant graph will appear? Where the first signal will start? U of t plus 1 means it is starting at minus 1. U of t plus 1. Second signal is ut, but it is having amplitude of minus 2. Last signal starts at t equals to 1, having amplitude of 1. These 3 signals we are doing addition. We want to add these 3 signals. So try to observe the 3 signals over their discontinuous instants. Try to observe the 3 signals for their discontinuous instants. First change of interval is minus 1 to 0. Next change of interval 0 to 1. For the interval minus 1 to 0, which signals are defined? Only the first signal, 1 plus 0 plus 0. Observe all the 3 signals for minus 1 to 0 interval. 1 plus 0 plus 0 means answer becomes 1. What about 0 to 1 interval? 1 plus minus 2 plus 0. 1 plus minus 2 plus 0 means it will come to minus 1. After 1, sir, t greater than 1, what will be the result? 1 plus minus 2 plus 1, it becomes 0. 1 plus minus 2 plus 1, it becomes 0. That is x of t. Try to add the 3 step functions for their discontinuous intervals. First interval minus 1 to 0, next interval 0 to 1, last one is after 1, t greater than 1. Okay, moving to next slide. Y of t equals to r of t minus r of t minus 1. Think of ramp signal starts at origin with slope of 1. Think of that. Ramp signal is starting at origin with slope of 1. So this is r of t. What is the meaning of r of t minus 1? It is starting at 1 with negative slope. It is starting at 1 with negative slope. After addition, what will happen? After doing addition, what will happen? 0 to 1 interval, the ramp segment as it is. 0 to 1 interval, the ramp segment as it is. After 1, for t greater than 1, positive ramp added to negative ramp. When both functions are added, it becomes constant. 0 to 1 interval, ramp segment as it is. For t greater than 1, positive ramp added to negative ramp means it becomes constant. T added to minus of t minus 1, amplitude is 1. In this example only, suppose we added another term like minus u of t minus 1. What is the change in the graph? Suppose we added extra term minus u of t minus 1. The above graph is r of t minus r of t minus 1. For that, extra minus u of t minus 1 is added. So what is the meaning of minus u of t minus 1, sir? From 1 to infinity it covers with amplitude of minus 1. So 1 to infinity segment cancelled. Because 1 to infinity here amplitude 1. For that we added minus 1 means it is cancelled. So what is the change in the graph? That is the change in the graph. Whenever I ask, write the mathematical expression of this triangular segment, most of the fellows will write y of t expressions are, be careful. So it is r of t minus r of t minus 1. What is the extra? Minus u of t minus 1 is also added. That is extra. Minus u of t minus 1. Okay, moving to next slide. Please think about this example, everyone. Sum of 4 ramp signals given, sir. Ramp signal nature is wherever it starts, it may start with positive slope or negative slope. So in this example, 2 ramp functions have positive slope, 2 ramp signals have negative slope. When you try to add these 4 ramp signals, you will get the resultant graph. So make a try and tell me sum of the ramp signals. What is the resultant graph? Ramp signal nature is wherever it starts, it may start with positive slope or negative slope. First, you indicate the change of instants. At which instant the changes are occurring, sir? From the given mathematical expression, at which instant the changes are occurring? -2, -1, 1, 2. First, the ramp signal starts at -2 with slope of 1. It is a positive ramp with slope 1. M for slope. M for slope. That slope is maintained till -1. If you want, I will write the mathematical expression also clearly. For the first interval, it is just t plus 2, positive ramp. But at t equals to -1, what is the new slope we are expecting, sir? At t equals to -1, what is the new slope we are expecting? -1. Existing slope 1. 1 plus -1 becomes 0. Slope cancellation. Till -1, its slope is 1, but at t equals to -1, we want new slope of -1. 1 plus -1 becomes. So for the interval -1 to 1, first 2 functions are added. Answer is constant. For a constant signal, slope is 0. If you take a constant signal, its slope is 0. Okay. Till t equals to 1, its slope is 0, sir. Everyone see here. But at t equals to 1, what is the new slope we want? -1. Existing 0, we want -1 means 0 to -1 drop or raise. 0 to -1 means raise, drop. So for the interval 1 to 2, 1 added to minus of t minus 1, that is 2 minus t, a negative ramp. Till 2, its slope is -1. But at the last instant at t equals to, what is the new slope we want, sir? +1. Existing slope -1, -1 plus 1, cancellation. -1, slope cancellation. So resultant graph is a trapezium. Nagarjuna Rao, good. Ramp signal will have certain slope. Constant signal means what is the slope? 0. Ramp function will have certain slope. Constant signal means slope is 0, sir. Fatma, Ayushi. And one more simple point I want to tell you. I'm going to next slide, sir. Suppose a signal x of t is given like this, sir. And ask us to get what is the ramp expression. X of t is given. We want to get what is the mathematical expression of that signal. For the interval pi to 2 pi, what is that expression? Everyone see here once. Actual technique is y minus y1 is m into x minus x1. Directly let us find out what is the slope of this. Slope means height by width, v by pi. It is raising ramp means plus. Mx plus c styles are mx plus c. Slope is height by width, v by pi. X-axis time. X-axis time. But at t equals to pi, what is the amplitude we want to maintain? At t equals to pi, how much amplitude is needed, sir? 0. If I substitute t place pi, it becomes v. What extra to be added for making amplitude 0? Minus v. So t place pi means 0, t place 2 pi means 2v minus v, v unit satisfied. I am repeating one more time. So now, first we have to obtain the slope. What is the slope here, sir? Height by width, v by pi into x-axis time. If it is raising ramp, plus sign. If it is dropping, extra place, minus sign. But at t equals to pi, how much amplitude we are expecting? The signal has to be amplitude of 0. If I replace t as pi, it becomes v. What extra to be added, sir? Minus v. So vt by pi minus v for the interval pi to pi, pi to 2 pi. Mx plus c concept, nothing new we have done here. Simple mx plus c. Everyone respond correct expression of this in the chat box with the same logic. What is y of t expression for 0 to 2? Think of. Use mx plus c logic. Bhanu Prakash correct. Swastik correct. Find the slopes there. Dwarakanath, you are also right. Akhil correct. Venkatramana, check the slope. Nitish, you are right, sir. Mohammad Bhai, positive RAM, negative RAM, dekho. See it properly. Kiran Kumar, correct. Probably still you are in drowsy mode. Sunday enjoyment. First to find out the slope. What is the slope, sir? Height by width. 4 by 2 is 2 because it is decaying ramp, extra minus sign compulsory into t. But at t equals to 2, how much amplitude we need, sir? 0. If I replace t as 2, it becomes minus 4. If I replace t as 2, we need how much? Amplitude as 0. If I replace t as 2, it becomes minus 4. Extra term to be added is plus 4. Of course, at 0, also it is obeyed, sir. If you replace t at 0, 4 units. Raising ramp plus sign, dropping ramp minus sign. When you are writing the slope, sir. What, Nagarjuna? Why extra 8 number? Check it. You have given all correct answers still now. No confusion here. What is there to confuse? Idhar dekho one more time. At t equals to 2, we want how much amplitude? Just think of at t equals to 2, we want 0. Minus 2 into 2 means minus 4. What extra to be added? At t equals to 2, to get the amplitude as 0, extra 4. 4 number to be added. Good, good. Why I am explaining the simple point is, whenever this type of expressions comes up, I will write it directly. So don't ask me again how you have written it. Simple mx plus c logic. Okay. So the beginning problems we observed is mathematical expression to graph. Now I will give graph. Try to write the mathematical form of them. From the graph, how to write the mathematical expression. Express the signal in terms of singularity functions. Express the given signal in terms of singularity functions. This is the signal graph given, sir. Try to write that as sum of step and ramp. Singularity functions means try to express the given signal as sum of step and ramp functions. What Sahiti, what I asked and what you are writing? What second graph? I think still you are in previous problem. Take the slopes properly, everyone. -4 to -2 interval, what is the slopes are? Height by width. Height by width. Constant signal means slope 0. Next again, constant 0, sir. 4 to 5. What is the slope? -3. After 5. After 5, constant signal means slope 0. First to find the slopes properly. Okay. Listen. First ramp signal starts at -4 with slope 1. So first term is r of t plus 4, sir. Its slope is 1. Starting at -4. 1 into r of t plus 4. But at t equals to minus 2, we want zero slope. Existing slope 1, but we want zero slope means introduce negative ramp of opposite slope. To cancel that effect, introduce negative ramp of opposite slope. Next change has occurred at 0 where we have jump of 1 unit. Jump is caused by step function. Where we have jump of 1 unit. The jump is caused by step function. Next change has occurred at t equals to 4 where the 0 slope becomes minus 3. 0 to minus 3 means drop or rise. We are at 0. We want to come to minus 3. 0 to minus 3 means drop or not. So minus 3 into r of t minus 4. So that slope is maintained till 5. But at till 5, at 5, what is the new slope we are expecting, sir? 0. Existing minus 3. So to cancel that effect, introduce positive ramp of opposite slope. Introduce positive ramp of opposite slope. Listen one more time. First ramp signal starts at minus 4 with slope 1. That slope is maintained till minus 2, sir. At t equals to minus 2, what is the new slope we are expecting? 0. So to cancel that positive ramp effect, introduce negative ramp of opposite slope. Next change has occurred at 0 where we want jump of 1 unit caused by step function. At t equals to 4, 0 slope becomes minus 3 means drop. Minus 3 into r of t minus 4. At t equals to 5, try to cancel that negative ramp effect by introducing positive ramp. Bhanu Prakash, good. Swastik, you missed the last time. Okay. Typing is not easy. No problem. At least you have tried it. Very good. Observe the slopes correctly. Change in slopes also correctly. 0 to 1 or 1 to minus 1 like that. Change in slopes also check properly, sir. Then only you can write the expression in a correct way. Okay, I'm moving to next slide. Please think of this. How to write this signal expression as sum of step and ramps are. Think of what Pujita. इधर देखो till 5 it has maintained slope of minus 3 ma. So at t equals to 4 there is drop in the slope 0 to minus 3. But at 5 what is the new slope you want? 0. Existing slope minus 3. But you want 0 slope means to cancel that negative ramp effect what you have to introduce at 5. Positive ramp of opposite slope. So the last term is 3 into r of t minus 5. 3 into r of t minus 5. Okay. Make a try, sir. This model 1.5 to 2.5 the signal covers. Of course, the slope is 1, sir. Slope is 1. Directly at 1.5, we have jump of 1.5 units means caused by step function. Directly at 1.5, we have jump of 1.5 units means caused by step function, sir. Later on, at the same instant, it is raising ramp with slope 1. Later on, at the same instant, raising ramp with slope 1. So plus r of t minus 1.5. Plus r of t minus 1.5. Next change has occurred at 2.5, where we have to cancel this positive ramp effect first. We should make that as zero slope. Of course, it is not visible in the graph, sir. Make it as zero slope. Introduce negative ramp of opposite slope there. Introduce negative ramp of opposite slope. Immediately, what happened after making zero slope? Immediately, what happened? At 2.5, negative jump has occurred. At 2.5, negative jump has occurred. So minus 2.5 u of t minus 2.5. At the instant 1.5, two things were happened, sir. One is a positive jump of 1.5 units, linearly increasing ramp with slope 1. At 2.5 also, two things were happened. One is cancellation of positive ramp effect, negative jump. 2.5 to 0 drop, negative jump. Very good. Most of you typed, but emotionally something you have missed in the expressions. It's okay. When you have simple expressions, then only types are. Don't waste your energy levels, because simultaneously you have to do so many things. Simple numbers, any number problem, those things you please type. Everyone think of this. Now you tell me how to express this signal as sum of step and ramp function. Carry on. Take the slopes. Slopes are here 2 by 2, that is plus 1, not plus 1, minus 1, decay. It is a decaying ramp. Minus 1, 2 to 4 interval, plus 1, sir. Okay. First, the signal starts at 0 with jump of 2 units means first term 2 ut. Next at 0, it is dropping. So minus r of t. Minus r of t. What happened at t equals to 2, sir? Before 2, its slope is minus 1, but after 2, it becomes 1. We are going from minus 1 to 1 means raised by 2 units. Before 2, it is minus 1, but expected is 1 means it is raised by 2 units. 2 into r of t minus 2. At t equals to 2, slope minus 1 change to plus 1, sir. So plus 2 into r of t minus 2. 2 to 4 interval, the slope is how much? 1. First, we have to cancel the effect. 2 to 4 interval, slope is plus 1. Introduce negative ramp of opposite slope. Finally, at 4, negative jump has occurred. Finally, at 4, negative jump has occurred. First term is 2 ut. At the same instant, it is decaying ramp minus r of t. At 2, minus 1 slope change to 1 means raised by 2 units. Minus 1 to 1 means raised by 2 units, sir. At t equals to 4, cancel that effect. Cancel the positive ramp effect. For that, we introduce minus r of t minus 4. last instant negative jump has occurred. Negative jump has occurred. Akhil, at 2 the slope is changed to 2, sir. At t equals to 2 the slope is changed to 2. Observe that properly. Normally in competitive exams, what that fellow will do is, by giving the signal graph, he may ask for get the Laplace or Fourier, sir. If you write the mathematical expression correctly, then only you can say what is the respect to Laplace or Fourier. First of all, you are in a position to write the mathematical expression correctly. Okay. Like we discussed, some of the standard continuous signals in discrete form also we have 2 standard signals are in discrete form. One is named as unit step sequence. One is named as unit step sequence represented as U of n. From 0 to infinity, every sample is 1. Unit step sequence means from 0 to infinity, every sample amplitude is 1. So don't feel this as sampled version of ut, sir. We studied very clearly u of t is discontinuous at origin, but u of n has clear sample amplitude of 1. It is a predefined signal. Mr. Venkatramana, you have asked me this question. This is not the sampled version of ut, sir. It is a predefined discrete signal. If it is sampled version of ut, no value at origin. So it is a predefined discrete signal. Unit step sequence. Second one is discrete impulse or Kronecker delta. Continuous impulse name Dirac delta, discrete impulse name is Kronecker delta, sir. It is defined only at origin with amplitude of 1. Continuous impulse amplitude infinity, discrete impulse amplitude is 1. Continuous impulse is used only for mathematical analysis. Then how to generate practically only one sample of the signals, sir? How will generate practically only one sample of the signal? We will go for a discrete impulse. We'll go for a discrete impulse. Be careful with representation. Continuous impulse is like arrow mark. Discrete impulse is represented with a dot. Discrete impulse is represented with a dot, which always maintains finite amplitude. So, if I ask you what is the relation between these two signals, are un in terms of del n or opposite way? How to write un in terms of del n or opposite way? U of n is clearly looking like sum of shifted impulse or not. Del n minus 1, del of n minus 2, like that. Sum of shifted impulses. For addition, what is the opposite operation, sir? Subtraction. For addition, the opposite operation is subtraction. But in signal subject, I will always use a simple logic. Everyone first listen my explanation, after that you note down, sir. First listen my explanation carefully. If you know continuous formulas, automatically we'll get the discrete formulas. Continuous case, we have written d by dt of ut is del of t. Opposite way, unit step is running integral of impulse. Whenever we know continuous formulas, we are getting the discrete formulas also. Continuous case, when you have differentiation, everyone see the screen, sir? When you have differentiation, it is converted to difference in discrete. Continuous case integration means the equivalent term is summation. So differentiation converted to difference, integration converted to summation. That is the logic we are following to convert continuous formulas to discrete, sir. Because we have first differentiation, discrete case is called as first difference. In numerical methods, how we are writing first difference formulas are? In numerical methods, what is first difference formula? Xn minus x of n minus 1. So tell me, del t is now replaced as del n, ut is now replaced as un. So the answer is un minus u of n minus 1. First differentiation converted to first difference. Ut becomes un, del t becomes del n, sir. Un minus u of n minus 1. You can check that graphically also. What is u of n minus 1 meaning? The samples are extended from 1 to infinity. After subtraction, what you are left with, sir? Un minus u of n minus 1 means we are left with impulse at origin. That is what we have written here. Del n is un minus u of n minus 1. What is opposite change here? Integration is replaced as sigma. The variable t is replaced as n. Tau is replaced as k. Do the notational changes. Integration becomes sigma. T is replaced as n. Tau is replaced as k. So what is the change in the formula? Un equals to sigma minus infinity to n del k. Sigma minus infinity to n del k. See the notational changes. Integral place sigma, t becomes n, tau becomes k. So when you look at this formula, you may feel it is wrong relation because un graph starts from 0, whereas here we are varying summation from minus infinity to n, sir. This formula we got because of notational changes. Again, you modify that as 0 to infinity limits. Again, you modify the summation limits as 0 to infinity. Suno, listen here. So let us modify the limits. I am taking n minus k with a variable m. I want to change k limits to m limits. If k is minus infinity, what is equivalent m value, sir? Plus infinity. If k value is n, what is m value? 0. So u of n is sigma m equals to infinity to 0 del of n minus m. See the notational changes. Minus infinity becomes plus infinity. Upper limit n becomes 0. K place I have written n minus m. Because it is addition, 0 to infinity or infinity to 0 meaning is same only. Because it is addition. When you expand this, it will look like our graph. Del n minus 1, del of n minus 2, like that. So for u of n, two formulas are correct, sir. This is correct. This is also correct. First formula we got because of notational changes. Second one is actual style. Leave the mathematics we have done, sir. In the process of converting continuous to discrete, what is the logic we have to follow? Everyone say with me. Even you are at home, say with me. Differentiation converted to difference. Integration converted to summation. This logic will follow blindly till the completion of the subject, sir. If I write continuous formulas, you are in a position to say discrete formulas. So what changes we are making for that? Differentiation is difference, integration is summation. Just go through it, everyone. Differentiation converted to difference, integration converted to summation. differentiation converted to difference, integration converted to summation. Just go through the relations, sir. What Swastik? That is what I have done. This ut equivalent is un in discrete. Del t becomes del n. Un minus u of n minus 1. Not a problem. Continuous case differentiation means here it becomes difference, discrete equivalent. For ut, you cannot use the word difference. Continuous means differentiation. Discrete, difference. Yesterday, I observed in Telegram channel that some students are asking when signals will be completed. No hurry, yaar. If you study in hurry manner, nothing you will get. I know GATE exam is in February, even ESC prelims also. So with emotions, you will not get concepts. Yes, Swastik, you are right. But R of n need not be treated as n into un. Okay. So learning is most important. It's not how many number of hours the class is going on. From last 2 months, continuously I'm taking batches online and offline. So don't bother about how many number of friends the show is running. You bother about how much you have learned. That is most important because you are writing the exam. It's not we. It's only my suggestion. Take it in positive manner, sir. Don't expect how many number of hours the class runs. How much you have learned is important. I mentioned with you yesterday only roughly 60 to 65 hours I am covering the syllabus, roughly. So if it is average 3.5 hours also, 18 to 20 days, roughly. 18 to 20 days. And you have so many other subjects also now. Parallelly you study. This subject is more logical. Analog signal subjects are logical subjects. Just like that you will not get. Even we know some simple blunder mistakes you may do. So you must be careful in learning process, sir. This is the only subject for left for you. Only signals is left, online batches. Because recently only I have completed offline for EC as well as electrical, even instrumentation fellows also. Acha. Some fellow is saying EDC also. Okay. Acha. For few batches it is EDC also. For some fellows SS. Don't bother. Study with me parallelly. If I discuss the class for 3-4 hours, at least it will take double the time for understanding the concepts. So try to make review regularly make a review. Okay. Continuous case differentiation means discrete case difference. Continuous case integration means discrete case summation. We studied continuous case scaling property of impulse del of alpha t as 1 by mod alpha times del t. Del of alpha t as 1 by mod alpha times del t. What is the change in discrete, sir? What is the scaled form of discrete impulse del kn? If you want to scale the discrete impulse by a factor k, what will be the answer in terms of del n? If you want to scale the discrete impulse, what is the result? Del kn is always del n only. But we studied del of alpha t as 1 by mod alpha times del t. Why del kn is del n, sir? If you want del of 4n, it is 1 for 4n equals to 0 implies n equals to 0. Same as original definition. The scaled version of discrete impulse is itself. The scaled version of discrete impulse is itself. Why we got 1 by mod alpha there? Because it is area concept. Because it is area concept. Continuous impulse is dealt with area, sir. But discrete impulse is considered only with amplitude. Out of all standard signals we studied, the only signal that is represented by area concept is continuous impulse. Out of all standard signals we studied, the only signal that is represented by area concept is continuous impulse. Latest ESC objective, this funny question is asked. Latest. What is the value of this summation? Sigma minus 525 sine 2n into del of n plus 7. Everyone should respond. Very funny. Zero is the answer. Very good. Because where impulse exists, sir? Impulse we have taken at minus 7. But what is the range of index? Minus 5 to 5. Sine 2n is the function that is covered for minus 5 to 5. But impulse is taken at minus 7. Outside the range, answer is 0. It is like shifting property of discrete impulse. Their integration is here, summation. Very funny and easy. Like we observed transformation of continuous signals, let us see transformation of discrete signals with examples. Certain examples, scaling, shifting and reversal concept with some examples, sir. Suppose if we have taken a discrete signal like this, sir. A discrete signal is taken with certain amplitude levels. For this signal, how to generate these different combination of signals? If we have taken a discrete signal for certain index 0 to 5, how to generate these different combination of signals? Take one by one. What is the meaning of x of n plus 3? Like t minus t naught, it is n minus n naught symbol here. Like t minus t naught, it is n minus n naught symbol. Try to shift the original signal left by 3 samples. Try to shift the original signal left by 3 samples. So if you add minus 3 to the index, where it is covered, sir? If you add minus 3, it extends from minus 3 to 2. Left shift of 3 samples. Second signal, of course, we know first scaling, then shifting we are doing, sir, generally. So first time reversal, after getting the time reversal signal, shift that signal right by 6 units. First you have to get x minus and right shift of 6 units. Where we have to sketch the signal, two times. First folding, later on right shift of 6 samples. Instead of that, let us follow another easy technique. What is the other easy technique is, before finding any of the discrete signal given here, sir, before finding any of the discrete signal given here, we can observe that for what index the respective signal is defined. Before finding any of the discrete signal given here, we can observe that for what index respective signal is defined. Listen carefully. X of n is defined for what index, sir? 0 to 5. X of n is defined for, X of n is defined for 0 to 5. So let us find the limits of x of 6 minus n. Let us find the limits of x of 6 minus 0 less than or equals to 6 minus n less than or equals to 5. Here solve for n limits. If you subtract 6, minus 6 less than or equals to minus n less than or equals to minus 1. 6 greater than or equals to n greater than or equals to 1 means the index is 1 to 6. Listen. For getting the signal x of 6 minus n, we have to take index from 1 to 6. For getting the signal x of 6 minus n, index is 1 to 6. Then how to know amplitude, sir? If I substitute n place 1, that becomes x5. Everyone see the graph you have drawn? What is x5 sample from original signal? x5 value how much, sir? 1. N place 2 means it becomes x of 6 minus 2. That is x4. From original signal decide the amplitude level. N place 3 x3. N place 4 x2, like that. From the original signal decide the amplitude level. After solving for the index, for each value of n, get the amplitude from our original signal. If I substitute n place 1, the y-axis becomes x5. What is x5 sample from original signals are 1. Like that you draw. What is the advantage of this method, sir? Only one time we have completed the signal. I think some of you have done already the original procedure. First reversal, right shift of 6 samples. Whether you got this graph or not, sir. First reversing, right shift of 6 samples. I hope 100% you got this graph. Instead of that, follow this way. Easy. Solve for the index, get the answer. Okay, that is a second signal asked x of 6 minus n. The third signal expected is x of 3n plus 1. Can you solve by first scaling then shifting concept now, sir? Can you solve by first scaling then shifting concept now? No, it fails. Because once you take 3 common, it becomes n plus 1 by 3. We can scale by 3 samples, that is okay. But what is the shift value we got? Minus 1 by 3, meaningless. First scaling then shifting failed because we got non-integer shift. First scaling then shifting failed because we got non-integer shift. What is the other easy technique? Just now we checked. Solve for the index. Make a try. Solve for the index, sir. Xn is defined for 0 to 5. So x of 3n plus 1 is defined for which index? X of 3n plus 1 is defined for which index? N is replaced as 3n plus 1. What, Sadhanand? Subtract 1 first. Subtract 1. Then perform division by 3. For minus 1 by 3 to 4 by 3, which are the valid integer samples, sir? It is lying in the range minus 1 by 3 to 4 by 3. Means 0.33 to 1.33. Which are the valid index for us? Only 2 samples, 0 and 1. It is valid only for 2 samples, 0 and 1. Tell me how to get amplitudes. N value 0 means x1 sample. What is x1 sample from original signal amplitude? How much, sir? 5. N value 1, if I substitute, it becomes x4. What is x4 sample from original signal? What is x4 amplitude from original signal, sir? 2. First solve for the index. Then you draw the graph. What, Swastik? Index method also failure. Then how we decide 0 and 1 samples? You should consider the index which are lying within that range, sir. Which are the integer samples there? 0 and 1 are valid samples. But what happened to the number of samples now? They have been reduced. They have been decreased. Original signal 0 to 5 means total 6 samples are there, sir. 0 to 5 means total 6 samples. Now they become just 2. Now they become just 2. So time scaling notation we have taken in discrete case as x of mn. Now that m number is 3 greater than 1, that is called as the decimation or downsampling. Decimation or downsampling. Number of samples are decreased. Original length is 6 samples, but now it becomes only 2 samples. Other samples are neglected in decimation process. First thing, decimation means it will give us loss of information. Interpolation will retain the content. Wait. Why it is not integer value here? 0 and 1 are not integer. Original signal length is 6 samples. As the scaling factor is 3, 6 by 3 becomes just 2 samples. 6 by 3 becomes 2 samples. But inside the computer, how x of 3n plus 1 is generated? If you are available with xn, how x of 3n plus 1 is generated? We observed first scaling, then shifting failed. But what is the other technique we know, sir? What is the other technique we know? Shifting, then scaling. Let us observe whether that process gives us same result or not. Shifting, then scaling. So first you take x of n plus 1. X of n plus 1 meaning is original signal left shifted by 1 sample, sir. X of n plus 1 meaning is original signal left shifted by 1 sample. So where it covers? The samples are from -1 to 4. X of n plus 1. Name that as yn. Name that as yn. Immediately we want y of 3n. Immediately we want y of. See here everyone. Multiplication here becomes division in the time index. Which samples are exactly divisible by 3, sir? To make n as integer. Whatever the circle I have done, those samples are exactly divisible by 3. Samplet 0 is retained as 0 only. Samplet 3 now becomes 1. Samplet 3 now becomes. So inside the computer, what we'll do? First we'll advance by 1 sample, then selection of alternation of 3 samples, decimate by 3. Decimate by 3. Left side technique is useful for competitive exam point of view. Inside the computer, this is the technique followed. First advance by 1 sample, then decimate by 3. What's first take? Now we got the result or not? First scaling, then shifting failed means we are using opposite styles are shifting, then scaling. Left side technique is useful for competitive exams. Easy way to answer. Right side is the general technique followed. Anyway, main observation is here decimation. Continuous case compression is now called as decimation. Their compression is here decimation. Everyone think of x of n by 2. For x of n by 2, what is the range of index? Original index 0 to 5. For x of n by 2, what will happen? What is the range of index? N is replaced as n by 2. N is replaced as n by 2 means 0 to 10. So for getting the signal x of n by 2, the range of index varied is zero to 10. We have to vary from 0 to 10. Yes, Surya. Tomorrow 2 hours only I am taking. You're right. But which are the valid index, sir? Compulsory to make n by 2 bracket term as integer. N must be integer multiple of 2. If you take n equals to 0, x0, 6. N equals to 1, no value. X of 1 by 2 is not defined. N plus 2 means x1 is 5. This I am deciding from original signal only, sir. From original signal amplitude only. Please cross check from your notes because that graph is available with you. N value 3, no answer. At 4 it becomes x2. At 6 it becomes x3. Like that. Only for multiples of 2 the answer is retained. Only for multiples of 2 the answer is retained. So now x of mn form m value half. M value half less than 1 greater than 0, it is called as interpolation or upsampling. Interpolation or upsampling. To be specific, this answer is called as zero interpolation, sir. Because we have taken some of the middle samples 0. Original amplitudes are 6, 5, 4, 3, 2, 1. I am writing the amplitude in set form. Middle samples are all zeros. Middle samples are all zeros. If you want, you can make last sample 0, sir. Everyone listen this point carefully. Interpolation is not unique. That you want to interpolate the signal, it is not unique procedure. You may solve the same problem by step interpolation concept. In step interpolation, what we'll do is, to get the step function means constant amplitude. Whatever the previous sample is there, that is taken as it is, sir. At 1 answer 6, at 3 it is 5, like that. The previous amplitude is retained as it is in step interpolation. You can solve the same concept by linear interpolation also. Linear interpolation. So now the answer becomes what? Linear means you want to form straight line. In the process of combining those samples, you want to form straight line. So try to select a middle sample that I have shown roughly with green color. So average. We are placing average of samples. 6 plus 5 by 2, 5.5. So here it is 5.5. Next one 4.5. Here we are actually using a concept as step size. 5 minus 6 by 2, that number must be added, which is minus 0.5. Suppose if you want x of n by 3, sir. If you want x of n by 3, 5 minus 6 by 3 minus 1 by 3 added 2 times. Okay. Why multiple forms of interpolation? I'll give that explanation in the next slide. First, you note on this. Zero interpolation means middle value zeros. Step interpolation means previous amplitude is retained. Linear interpolation means average. Linear interpolation is average. We retain the previous value in step interpolation. But in linear interpolation, what we are doing, sir? Average adjacent sample values. We are doing averaging of adjacent sample values. First you note down, then I will discuss the reason for you. Okay, I'm going to next slide. Why interpolation is multiple forms when decimation is unique means in the process of converting the sample form of the signal back to continuous, what type of reconstruction technique that is used, that is unknown, sir. Suppose you want constant type of approximation, this graph is approximated to like this. If you want ramp type of approximation, same graph is approximated like this. This technique is called as curve fitting. From the sampled form of the signal to reconstruct our original continuous signal, what type of approximation is done, that is unknown. If you want constant approximation, which interpolation technique you have to follow? Step interpolation. If you want ramp type of approximation, then we have to follow which technique? Linear interpolation. Depending on the required shape, that form of interpolation is used. This point I am explaining under sampling theorem, flat top sampling, not immediately after 30 hours. When I am explaining flat top sampling, I will discuss these circuits there. Zero order hold circuit, first order hold. As of now, you remember why multiple forms of interpolation is needed means in the process of recovering the continuous signal graph, what approximation is done, no one knows. Depending on the requirement, any one technique, sir. Depending on the requirement. Okay. First of all, what is the need of both decimator and interpolator means if we want to convert one sampling rate to another sampling rate, that concept is called as multi-rate signal processing. Wherever you want to change the number of samples, that is called as multi-rate DSP. One practical example to give, ITU, International Telecom Union, they have fixed for a CD player sampling rate of 44.1 kilohertz. Another system like DAT, digital audio tape, for that they have fixed 48 kilohertz. Assume these systems are interconnected, but their input rates are different. CD player is asking for 44,100 samples. DAT is asking a different rate, 48 kilohertz. So mathematically, we should make 44.1 as 48. Some mathematical enjoyment is needed. It is not exact, like 4n by 5. So, which includes both decimation and interpolation or not? Which includes both interpolation and decimation. One easy example I am giving, if you are available with 32 kilohertz and you are expecting 48 kilohertz, in the process of converting 32 to 48, what we'll do? 48 by 32 is 3 by 2. Take 32 kilohertz in the beginning, upsample by a factor 3, that becomes 96 kilohertz. Then you downsample by a factor 2, 96 by 2 becomes 48 kilohertz. In the process of converting one sampling rate to another sampling rate, we are in need of using both interpolator and decimator. This concept is given by an Indian Vaidyanathan. He has given this concept. Initial days, when samplers are used, sir, from the beginning to ending, we use it to have same sampling rate. But from last 20 years, we are using sampling rate converters where one rate is modified to another rate. For example, to say in India, our channels will have different sampling rate compared to other countries. Like electricity, our frequency 50 Hz, USA it is 60 Hz. In a similar way, our sampling rates are different, other countries' sampling rates are different. But we are in a position to watch information like BBC News that is broadcasted from other countries. What they will do is in the transponder, we are using a sampling rate converter where our FS number is modified to their number. In the transponder, that is equipment where our sampling rate is modified to their rate, automatically we are in a position to capture that information. So wherever you want to change the number of samples, that is indirectly requirement of which blocks? Interpolation and decimation. But the care we should take here is whenever you want to do both operations at a time, first compulsory interpolation, then only decimation. Otherwise, loss of signal content. Whenever you want to perform both operations simultaneously, sir, compulsory first perform interpolation, then only decimation. Don't have a wrong thought. When you increase the sampling rate by 3, we are increasing channel width, sir. Listen, when you interpolate by a factor 3, we are simultaneously transmitting 3 samples of the signal. 0, 3, 6, 9 are first signal samples, sir. 1, 4, 7 are second signal. 2, 5, 8 are third signal. Based on the interpolating factor we are choosing, that many signals are transmitted. Okay? So wherever we are using sampling rate conversion, automatically we need it. FFT algorithm, where we are using a decimation process, fast Fourier transform, that is also linked to this. So let me write that statement very clearly for you. Inverse of interpolation is decimation, but converse statement is not necessarily true. From the decimated signal, you cannot guarantee same interpolated signal. The reason, how many forms of interpolation we studied here? Zero interpolation, step interpolation, linear interpolation. Interpolation technique is not unique, sir. Interpolation procedure is not unique. So, inverse of interpolation is decimation. From the decimated signal, same interpolated signal need not be guaranteed. Whenever we have to perform these two operations simultaneously, first to do interpolation, then decimation. That is extra care we have to take. If you do reverse way, loss of signal content. Okay. So these are the answers we have written. Why multiple forms of interpolation means, this is the explanation. From the sampled form of the signal to reconstruct original continuous signal, what type of approximation is done, that is unknown. That is the reason multiple interpolation techniques. In the examination, just you, if that fellow has used the word just interpolation, sir, it is always zero interpolation only. Otherwise, they will clearly mention whether we have to apply step interpolation or linear interpolation. Just go through the slides. So inverse of interpolation is decimation, but reverse weight is not necessarily true. Generally, decimation reduces the storage requirement. Interpolation will preserve the fidelity. Fidelity means reproduction of original signal. Decimation is reducing the storage requirements, sir. Interpolation is preserving the fidelity, reproduction of original input signal as it is. So everyone tell me, zero interpolation means middle we are padding zeros. Step interpolation means previous amplitude is retained as it is. But linear interpolation, what we are doing, sir? Step size 5 minus 6 by 2, that is minus 0.5 is added to previous value. Suppose if it is x of n by 3, think of what is the enjoyment. 5 minus 6 by 3 minus 1 by 3, 2 times you have to add. 6 minus 1 by 3, comma 6 minus 2 by 3. Step size we are introducing. Okay. So their compression is here decimation. Their expansion is here interpolation. Their compression is here decimation, sir. Their expansion is here interpolation. Please think of the last bit here. What is the last bit answer? X of n minus 1 into del of n minus 4. It is neatly looking like product property of impulse. So that is x of 4 minus 1 into del of n minus 4. Replace that index. What is x3 sample in the problem, sir? 3. Last one is product property directly n plus 4. x3 is 3. x3 is 3. Their compression here decimation, their expansion is here interpolation. This is asked in one of the ISRO exam to generate a fractional delay x of n minus m by n, that is called as fractional delay. Generally non-integer shift we are not performing, but radar signal processing expects the non-integer data also, sir. Only in radar we require that fractional delays because it has to capture every second information. Otherwise, if some deviation happen, we are not getting the required information. So what are the sequence of steps to be followed to generate fractional delay? It requires interpolation, decimation, as well as delay, sir. Tell me correct sequence. 3 steps are needed. Interpolation needed, decimation needed, delay is also needed. I want correct sequence. What is the correct sequence to be followed? Tell me. It is a 3-step operation. Come on, come on. What is the sequence to be followed to generate fractional delay? It requires 3 steps. Dinakar, no. Nagarjuna, okay. First you take xn, interpolate by a factor capital N. That is giving us x of n by n. Delay by m samples. n minus m by n, finally decimate by capital N. So if you decimate by capital N, small n is replaced as n into capital N. So that is simplified as what, sir? X of n minus m by n. First interpolation, then delay, finally decimation. 3-step procedure. Hardly we are doing a simple shifting operation, but we require 3 systems, sir. We are doing only shifting, but it is asking for 3 systems: interpolation, followed by delay, followed by decimation. Normal delay in signals is denoted as Z inverse. You give xn, it is producing output as x of n minus 1. Normal delay. But if you want fractional delay, what are the 3 systems we should cascade, sir? First interpolator, followed by delay, followed by decimator. Hardly what you are doing, shifting operation. Complexity of the equipment or not? Complexity of the equipment. Why discrete signal is neglected for non-integer values? With this, you can observe why discrete signal is neglected for non-integer value means complexity of the equipment. For doing hardly shifting operation, we require 3 blocks: interpolated, followed by delay, followed by decimator. That is another reason why discrete signal is taken only for integer index. First interpolator, delay, followed by decimator. Our interpolating factor, decimating factor, both are same, sir. Interpolating factor, decimating factor, both are same. Middle delay. Okay. Please think of this model, everyone. Consider the discrete time signal x of n equals to 1 minus summation is given. Find the values of m and n naught such that x of n is u of mn minus n naught. You want to write the given signal in terms of unit step sequence. So what is the scaling factor and shift value? Every one of you know what is un. U of n means 0 to infinity, every sample is 1, sir. Draw the signal graph, then you will get the idea how to write in terms of u of n, sir. 1 minus summation term, draw the graph. 1 in continuous case is 1 for all time. Discrete case also, every sample is 1. From minus infinity to infinity, every sample is 1. Try to draw the signal graph, then you can say what is m, what is n naught. Tell me, what is the scaling factor and shift value? Chandrika, correct mark. Come on, come on. One means all samples are one, sir, from minus infinity to infinity. All samples amplitude 1. What is the expansion of this sigma, sir? K plus 3 means del of n minus 4. Next to del of n minus 5. Like that till infinity. Summation samples are covered from 4 to infinity. One minus sigma is the signal graph. After subtraction, what will happen, sir? 4 to infinity, both signals have same amplitude. 4 to infinity, both signals have same amplitude. So the signal stops at 3 after subtraction. It is stopping at 3. 1 minus sigma term is the signal. Now you should get the idea how to write this signal in terms of known signal, that is un. U of n signal covers positive index, but our signal covers negative index, means immediately you should take u minus n. U of n covers positive index, but this signal covers negative index, means you should take reversal u minus n. Then it is right shifted or left shifted for getting x of n, sir? U minus n signal must be right shifted or left shifted for getting x of n? Right shifted. So u minus n signal right shifted by 3 samples. So it becomes u minus n plus 3. Compare with the given expression. M value minus 1, n naught value. We have negative index, positive index becomes negative index, means reversal. After that, right shift of 3 samples. After that, right shift of 3 samples. Correct or not? So by comparison, M is minus 1, N naught minus 3. One means one for all indexer. After expanding the summation, impulse are covered from 4 to infinity. 1 minus sigma is the signal graph where samples are covered from minus infinity to 3. How to write this answer in terms of un means simple thought. Which transformations to be applied? To convert positive index to negative index, we need reversal. After that, right shift. But the point to be observed in this question is how to write one for all index in terms of un. We have drawn the graph of one, sir. How to draw one for all in terms of un? 0 to infinity segment is un. Minus infinity to minus 1 segment is what? Minus infinity to minus 1 segment is u minus n minus 1. How to write one for all index in terms of un? What, Ravi? How it can be represented as u minus n minus 3, bacha? U minus n minus 3 means it extends from minus infinity to minus 3. But our signal covers till 3. Check your operations properly. If you write u minus n minus 3, that signal covers where, sir? Minus infinity to minus 3. But our signal covers till 3. So how to write one for all time in terms of un means positive index un, sir. Negative index what? U minus n minus 1. Continuous case, we studied the formula ut plus u minus t is 1 for all time. But discrete case, what is the change? Now we observed, sir. Un plus u minus n minus 1 is 1 for all n from the graph. Un plus u minus n minus 1 is 1 for all n. This relation, this comparison also multiple times I will ask you, be careful. Multiple times. ut equivalent symbol we got as un. Their ut now becomes un. Their u minus t is not u minus n, sir. What is the change? U minus n minus 1. U minus n minus 1. When we are discussing region of convergence of Laplace and Z transform, we require this comparison. So be careful. ut is like un, u minus t is like u minus n minus 1. For this comparison purpose only, I solved this question, sir. For this comparison purpose only. Tell me, what is review of these transformations? What you have to remember, every fellow? Scaling symbol we have taken as x of at, x of mn. A greater than 1 we called as compression. M greater than 1 is decimation. A less than 1 positive we called as interpolation. Sorry, emotional fellow, this is continuous now. Expansion. M value less than 1 greater than 0 is called as what, sir? Interpolation. What is shifting symbol? T minus T naught or N minus N naught. Both T naught N naught positive means which shift, sir? Right shift. If they are negative, which shift? Left shift. Last one is reversal. Reversal meaning is what, sir? Folding or flipping. Rotate the signal with respect to y-axis. Whenever these operations comes into picture, every fellow should respond positive manner. Even you are at home. X of at, a greater than 1 means compression, a less than 1 positive means expansion. That thought you should get immediately. Because if you are not thorough with these transformations, nothing you can do in signals, sir. You must be thorough with these transformations. These are the final things you have to remember. How much really you have understood this topic? Let me verify with a very simple example. The transformations topic. Everyone be ready. Be ready. I want a graph of these signals correctly. I want graph of these signals correctly. One signal I will draw for you. Ut is step function. If you draw these signals correctly, it means you have understood transformations. Carry on. What, Ayesha? What is your question? What is x of minus t minus 1? Where it is x of minus t minus 1, ma? This is u minus n left shifted by one sample means u minus n minus 1. Come on, bachas. I hope you have completed, sir. U of t minus 5 means 5 to infinity. U of t plus 5 means minus 5 to infinity. U minus t means minus infinity to 0. This is like u of minus of t plus 5. U minus t already available, having left shift of minus 5 units. Having left shift of minus 5 units. U minus t signal left shifted by 5 units. What about the last one? U minus t signal right shifted by 5 units, sir. U minus t available right shifted by 5 units. The other way, directly time reversal of this. If I substitute t place minus t in this expression, sir, it is u minus t minus 5. Just reverse it, this answer. Even the time reversal of this. If I replace t as minus t also, this answer. How many of you have drawn correctly? Acha, you have raised your hand, bachas. Okay. Very good. If you have done correctly, it means you have understood transformations in correct manner, sir. Okay. Even single mistake also you try to improve, sir. Very good. So you should not ask me in the coming classes when I am doing scaling shifting directly, sir, how you have drawn it. You should not ask me. Be thorough. Be habituated to it. Okay. Take break for 40 minutes. Next break, I'll give 20 minutes for you. Take 40 minutes break. After that, we'll start the new topic, energy power signals, classification of signals. So now it is almost 8:50, 9:30 I will start, sir. 9:30. Yes, I hope you are back. Have you completed your breakfast, sir? Everyone? Okay. We completed the transformations of independent variable, that is scaling, shifting, reversal. Let us see the classification of signals. Either we take a continuous signal or a discrete signal, they are classified into 4 to 5 forms. In that, the first classification is energy and power signal. Energy and power signal. Energy or power of a signal will describe the size or capacity of the signal. Energy or power will describe the size or capacity of the signal. How much of input information can be retained at the output side? For that, the mathematical measure is finding out the energy or power side. In communication, we are habituated to use the word SNR, signal power by noise power. If SNR is more, we are saying system performance is good. If SNR is more, we are saying system performance is good. So what is that parameter that is describing the system performance is good, sir? Calculating the respective energy or power. So don't compare this with physics statement. Energy can be neither created nor destroyed. That much buildup is not there. It is only a mathematical measure that will tell us how much of input information we are in a position to retain at the output side. Normally, initial days to find the size of the signal, we used to have technique as finding the area under the signal, sir. But what is the problem with this area under signal? If you want area under sine wave or cosine wave, the answer becomes 0. We are not getting any measure. So we started taking area under square of the signal, which is energy. We started taking area under square of the signal. So we can say the given signal is energy signal if it is greater than 0, less than infinity. The signal is power signal if the average power is finite value. Rate of change of energy is power. If the average power is finite value, then we can say the considered signal is power signal. What is definition of energy in a continuous signal x of t is limit capital T tends to infinity, integral minus t to t mod xt whole square dt. Whatever the signal we are taking, it may extend over infinite length. The meaning of saying t tends to infinity is whatever the signal we are taking, it may extend over infinite length. So what is the definition of power, sir? Energy per unit time. We are covering width of minus t to t means total width of 2t. Same formula, what is extra multiplier? 1 by 2t integral mod xt whole square dt. Actually, how we have written this relation, sir? Power across a resistor means standard answer is what? V square by R or I square R. R is a normalized load that is taken as 1 ohm. R is a normalized load that is taken as 1 ohm. In our relation, like V square or I square, what is the equivalent form we have written here? Mod xt square. Because the input signal we are applying is a voltage source or current source. But in signal subject, we will not use any specific word. It may be a voltage source or it may be current source, sir. Can you tell me what are the equivalent changes in discrete, sir? Why we have written magnitude here means for complex signals. For complex signals, we need modulus. mod xt whole square can be written as xt multiplied by x star t for complex signals. What is the change we are making for discrete, sir? The variable t is replaced as n, integration is replaced as summation. Integration replaced as summation. Limit n tends to infinity minus n to n sigma mod xn square. So what is the change in power? There 1 by 2t, now it becomes 1 by 2n plus 1. There 1 by 2t, now it becomes 1 by 2n plus y extra plus 1 means 0 is a separate sample in discrete. We are varying from minus n to n, sir. N tends to infinity. Minus n to minus 1, 0, 1 to n. Here we have capital N samples. Here also capital N. 0 is extra. Overall becomes 2n plus 1. Overall becomes 2n plus 1. So based on these mathematical relations, we are checking whether the considered signal is an energy signal or power signal. This is the most important topic. Of course, now we are discussing time domain. Frequency domain also will discuss as Parseval's theorem, sir. Most important topic. Listen very carefully. So why we are finding out energy or power of a signal means what is the answer we have to say? To describe the size or capacity, how much of input information we can retain at the output side. Further, the mathematical measure is calculating their energy or power, sir. Time average, Pratap, minus t to t means what is the total width? 2t, 1 by 2t. Average power, energy per unit time, rate of change of energy. That is the reason 1 by 2t extra. Time average concept. It is very easy to remember. Energy means integral signal whole square. Power means average. For the same integral, 1 by 2t extra multiplier. Continues to discrete, what is the enjoyment? T becomes n, integration replaced as summation, sir. So let us solve few examples on this concept, sir. I am moving to next slide. Suppose if you have taken e power minus t ut, a decaying exponential, is it an energy signal or power signal? A decaying exponential is given. Is it an energy signal or power signal? That is the question, sir. Very good, Suryateja. How to say the answer directly means, as small t tends to plus or minus infinity, if the amplitude of the signal is 0, such signals are energy signals. As t tends to plus or minus infinity, if the amplitude is tending to 0, sir, such signals are energy signals. At minus infinity, of course, amplitude 0. At plus infinity also it is tending to 0. Such signals are energy signals. If you want to know exact energy, calculate by applying definition. Limit t tends to infinity. It is a positive side signal, that is 0 to t. Actual definition is what, sir? Minus capital T to t. But here it is positive side, 0 to infinity range only. Square of the signal, e power minus t whole square. That is limit t tends to infinity 0 to t e power minus 2t. So limit t tends to infinity e power minus 2t by minus 2 over the limits. So 1 minus e power minus 2t by 2. As capital T tends to infinity, what will happen to exponential? E power minus infinity 0, answer becomes 1 by 2. Finite amount of energy or not? Energy is a finite number, finite amount of energy. That is what we stated directly. As the t tends to plus or minus infinity, amplitude is tending to 0. Such signals are energy signals. What will be the power in the signals are average power? What is extra multiplier for energy definition? What is extra multiplier? Limit t tends to infinity e by 2t. Finite by infinity becomes 0. Finite by infinity becomes 0. So an energy signal requires 0 average power. Whenever the considered signal is energy signal, average power will be 0. An energy signal requires 0 average power. Why we are saying power is 0 is power of a signal is calculated generally for infinite lengths. Finite by infinity becomes 0. Power of a signal is calculated for infinite length. Finite by infinity becomes 0. Energy signal requires 0 average power. The slide. Okay, 1 minute. Dekho ma. This is 16th. Suppose if we have taken e power minus 3t square, now you respond. The Gaussian functions are. Is it energy signal or power signal? Bell-shaped curve means Gaussian function. Is it an energy signal or power signal? Energy signal. Because it is also obeying the same condition or not. Plus or minus infinity amplitude tending to 0. It is energy signal, sir. If you want energy in this function, integral minus infinity to infinity e power minus 3t square whole square dt. Further it is e power minus 6t square. Area under Gaussian function, a standard formula is there. That is root pi by a. Root pi by, so root pi by 6. Root pi by 6. Finite quantity. Suppose we selected 1 by t. Now you think of, sir. Nagarjuna expected that. I'll ask that question. X into x is x square. Arey bacha. A power m into a power n. is a power m plus n, 3 plus 3, 6. Don't feel like t power 4. Good. What about 1 by t, sir? Comment. Energy, power, signal. If I take modulus of this signal and try to draw the curve, sir, as t increases, 1 by t decreases. At plus or minus infinity, amplitude may be 0. But at 0, what is amplitude, sir? Infinity. Such signals are neither energy nor power. At any instant of time, amplitude is tending to infinity means neither energy nor power. At any instant of time, amplitude is tending to infinity means it is treated as neither energy nor power. At plus or minus infinity, amplitude may be 0, sir. But at 0, it is expecting 1 by 0 means infinity. At any instant of time, amplitude is tending to infinity means neither nor. So you must be careful with our last statement. This statement is valid only for physically possible signals. Physical possibility means we are in a position to generate them in the lab. They should maintain finite amplitude level over the interval they cover, sir. They should maintain finite amplitude. Decaying exponential maximum amplitude 1, we can generate. Gaussian function maximum amplitude 1, we can generate. But this is expecting at 0 infinite amplitude level. So this statement is correct only for physically possible signals. The signals that can be generated in the lab. Only for that signal, the statement is meaningful. Now every fellow should respond. If I give continuous impulse, is it energy, power, neither nor? Del of t I have given. Pratap, I am asking the question, you have typed it. Continuous impulse amplitude, how much, sir? Infinite at origin. So automatically, which function? Neither energy nor power. At any instant of time, amplitude is infinity means neither energy nor power. At any instant of time, amplitude is infinity means neither energy nor power. So continuous impulse at origin, it is expecting infinite amplitude, sir. Neither nor. Neither nor. Step function of amplitude A. Is it an energy signal or power signal? Step function of amplitude A. Is it an energy signal or power signal, sir? A signal which maintains constant amplitude over infinite time is a power signal. Signal which maintains constant amplitude over infinite time is power signal. From 0 to infinity, we have amplitude of A, sir. A signal which maintains constant amplitude over infinite time is power signal. So if you calculate the power, limit t tends to infinity, 1 by 2t. Of course, signal covers for positive length 0 to infinity, a square dt mod xt square means, of course, it is simplified as a square by 2, sir. Integral becomes t, tt cancellation, a square by 2. Finite amount of power. What will be energy in the signal? How much energy? Without 1 by 2t multiplier, it is energy. Without 1 by 2t multiplier, answer becomes infinity. So a power signal requires how much energy, sir? A power signal requires how much energy? Infinite energy. Power signal requires infinite energy. Can a signal be both energy and power signal simultaneously? Can a signal be both energy and power signal simultaneously, sir? No chance. Because energy signal means average power 0, power signal means energy infinity. They are mutually exclusive signal. If it is one, it cannot be other. A signal cannot be both energy and power signal simultaneously. Energy means average power 0, power means energy is infinity. Neither nor, till now we verified one example, sir. A signal cannot be both energy and power signal simultaneously. Okay, sorry. Energy signal power is 0, power signal energy is infinity. Okay. So a signal cannot be both energy and power signal simultaneously. Now you answer me. Power in the signal 1 plus u of t. I am directly asking power. Oh, some people are joining now. Good morning. Great fellows. Probably they are masters in the subject. Now my question is, directly get the power in the signal 1 plus ut. Tell the answer, sir. Tanuja, how many times you'll ask, ma? I have shown already for you. Single fellow has not given correct answer. What is the power in the signal 1 plus ut is the question. Venkatramana correct. Shivam correct. Come on, come on. Chandrika correct, ma? One means one for all time. Ut means only for positive time. Sum of these two will appear like what? Negative time amplitude of 1, positive time it is 2, sir. So power in the signal is limit t tends to infinity 1 by 2t From minus infinity to 0, amplitude is 1 whole square dt. Whereas for positive time, 2 whole square. So first one is 1 by 2, next one is 2.5 watts. Most of you have said the answer as 1.5 by taking directly 1 means 1 square, ut means 1 square by 2. That is wrong. If you take signal whole square, if you take a square, b square, that is sufficient. We have 2ab term also, sir. Most of the fellows, for 1 they said 1 square. Ut means 1 square by 2. 1 plus 1 by 2 is 1.5. That is wrong. Signal whole square is the definition. A square, b square, 2ab. Be careful. Unnecessary emotion will cause loose motion in the exam hall. Be careful. To play with you, one simple question is sufficient. 50% of the fellows have typed 1.5, which is wrong answer. Our definition is yt whole square. Yt whole square meaning is what, sir? 1 square plus u square t plus 2 times ut. Those who have set the answer as 1.5, they have missed that term. So be careful, sir. Okay, I'm going to next slide. X of t is a cos omega naught t plus theta. Now, sir, energy signal or power signal? It is a periodic signal with amplitude variation of plus or minus a. Which signal? Energy or power? All periodic signals are power signals. RMS value whole square. A square by 2. RMS value whole square. All periodic signals are power signals. What about complex sinusoid? A e power j omega naught t. Complex sinusoid. Complex sinusoid is also periodic function. Magnitude of e power j theta is 1, sir. The power is limit t tends to infinity 1 by 2t integral minus t to t magnitude whole square. Of course, it becomes limit t tends to infinity a square by 2t. Answer is simply a square. Finite amount of power. All periodic signals are power signals. Except continuous periodic impulse train. That is an exception. All periodic signals are power signals except continuous periodic impulse train. Because just now we stated continuous impulse function is neither energy nor power, sir. Continuous impulse function is neither energy nor power. So all periodic signals are power signals except continuous periodic impulse train. Don't say vice versa. Power signal need not be periodic. Example is step function only. Step function we observed as power signals, sir, but it need not be periodic. Step function is power signal, but it need not be periodic. Don't say vice versa. That is wrong. Need not be. Okay. One simple question. If x of t is a periodic signal having its power as a p, what is the power in its scaled form? Xt is a periodic signal with its power p, sir. What is the power in the scaled form of that signal? Respond. The power remains the same is the answer. The power remains same. Because take this example. Last slide example. Xt is a cos omega naught t plus theta. What is x of 3t? A cos 3 omega naught t plus theta. Directly t plus 3t. There is change in frequency from omega naught to 3 omega naught, but still the power remains same. The power of a sinusoid or complex sinusoid has only amplitude dependency. When you scale the periodic function, only frequency differs, sir. Omega naught changes to 3 omega naught, still the amplitude remains same. Means the power remains same. Power remains same. For x of alpha t, the power remains same. The power of a sinusoid or complex sinusoid has only amplitude dependency. It is not depending on its frequency or phase angle. That we have shown from this example, sir. Xt is sinusoid, x of 3t is another sinusoid. Only frequency differs, which is not at all affecting the amplitude. So power remains same. What about shifted periodic signal power, sir? Shifted periodic signal power. That also remains same. That also remains same. Either you scale or shift the periodic signal, the power remains same. It is not affected. Think of this question, sir. Consider the periodic signal x of t shown below. This is the periodic signal graph given, sir, for us. The question asked is, what is the power in its scaled and shifted form? It must be same as original signal. What is the power in its scaled and shifted form? For any periodic signal, the total power is concentrated within one period, sir. For any periodic signal, the total power is concentrated within one period. Because we are repeating the same pattern, if you calculate the power for one cycle, that itself is total power. So what is the least period of the signal? I am assuming -2 to 1 segment as reference. Same segment is repeated from 1 to 4 also. So if you calculate power in x of t, that itself is total. Tell the answer, Bachas. What is the power in the signal? -2 to -1, no signal, sir. -1 to 1, it is a negative ramp. Mx passing through origin. So tell me the power in the signal. The power of any periodic signal is concentrated within one cycle. Chandrika, correct ma? Tell me the power, sir. Nitish, correct? Pramod Rao, check the answer. Correct, Venkatramana. What emotional fellow? That many times you have typed. One time it is sufficient. Like Rajnikant Basha, if you type one time 100 times, power in the signal is 1 by capital T means time period, of course, T0 is 3, sir. But -2 to -1, no signal. Amplitude 0. -1 to 1, it is signal whole square dt. 9 by 3 integral t square is t cube by 3. Answer is 2 watts. Answer is 2 watts. Of course, power in scaled and shifted form also 2 watts only. Time period is 3 seconds. You can take any reference interval, sir. -2 to -1 amplitude 0. -1 to 1 negative ramp. Whole square dt. Solve it. Answer 2 watts. Power of any periodic signal is calculated for one cycle. That itself is the total power. That itself is the total power. Take re bacha, who stopped you? 0 to 3 also you take. You should find out then 2 ramp expressions. Ask a proper question. Zero to one ramp, 2 to 3 another ramp. 2 times you have to do integration. Anything you can take. Suppose the signal graph is given like this. So you tell me It is acting like energy, power, neither nor. Constant amplitude of A for negative time, positive time decaying. Is it energy, power, neither nor? Think of and answer me. Carry iron fellow. For you only this question. It is a power signal. Limit t tends to infinity 1 by 2t. For negative time, what is the amplitude given, sir? Constant amplitude A square. Positive time, A square into e power minus 2t. Including 1 by 2t, second integral is 0. It is our first question. Check your notes. What is the average power in the decaying exponential we got, sir? 0. Average power in the decaying exponential, first example we got 0. So including 1 by 2t, second integral is 0, sir. Answer becomes simply a square by 2. It is a power signal. Only for negative time it is acting like power signal. Positive time it is acting like energy signal. So power signal added to energy signal means resultant is what, sir? We are adding power signal to energy signal means resultant is what? Power signal. Power signal plus energy signal means resultant is power. Negative time it is acting like power. Positive time energy. Sum of power and energy signal means resultant is power. Normally in communication subject we will say random signals are power signals, deterministic signals are energy signals. Random signals are power signals, deterministic signals are energy signals. Noise plus signal means overall noisy signal. Noise plus signal is noisy signal. Power plus energy is power. Power plus energy is power signal. Think of this question, everyone. X of t is given as two impulses. Y of t is integration of that signal. Find energy in y of t. X of t is given as two continuous impulses. Yt is integration of that signal. Get the energy in y of t. Hint is, what is the relation between ut and impulse? We know, sir. Integration of impulse is step function. Integration of impulse is step function. That is a hint. Please try to answer it. What, Dinakar? Check it properly. Carry iron. क्या हो गया? Instrumentation iron. Bhanu Prakash, correct. Shivam, check your answer. Somewhere you have done mistake. After giving hint also, you are giving wrong answer. You may be weak, but listen properly. Don't ask unnecessary questions. Okay? I am here to discuss out properly only. Maximum possible, I will simplify. Very good. 4 is the answer. So integral minus infinity to t del of tau plus 1 minus del of tau minus 3 d tau. Integral del tau is ut based on that first one u of t plus 1. Second one u of t minus 3. As integral del tau is ut, sir. First one u of t plus 1. Next one u of t minus 3. If you draw, it is a rectangular pulse having amplitude. So energy in the signal is minus 1 to 3 1 square dt. Amplitude is 1, sir. 4 joules. Minus 1 to 3 amplitude whole square. What is the length of this rectangular pulsar? Minus 1 to 3 means finite length. Amplitude of that signal also finite. Amplitude finite, length. Length or duration means time axis, sir. All finite length signals of finite amplitude are energy signals. All finite length signals of finite amplitude are which signals are? Energy signals. If the duration of signal is finite, amplitude is finite, automatically it is an energy signal. If I ask for energy in y of 3t, think of and answer me. In the same problem, if you have taken y of 3t, sir, now what will be the energy for that scaled form? What is the energy in y of 3t? Bhanu Prakash, Ravi, Ashish, very good. 4 by 3 is the answer. Y of 3t means compression or expansion? Y of 3t means compression. So let us assume E of y of 3t is minus 1 by 3 to 1 square dt. Answer becomes 4 by 3. 4 is of course original energy by 3. So in general, if you take y of alpha t, the respective energy is scaled by 1 by mod alpha units. Y of 3t means E by 3, sir. Y of 3t means E by 3. But for a power signal, what we observed, sir? The power remains same. For a power signal, the power remains same. Same question. If I change these two signals, what will be the energy, sir? Same example, if I change the signal as capital A into yt and A plus yt. For this, it is A square times original energy. Because our definition is integral signal whole square. A square y square t. Integral y square is energy. Integral signal whole square means a square. Integral y square is energy. Lower one, how much energy for a plus yt? Respond. What is the energy in a plus yt, sir? Very good, Ashish. Akhil, correct. Oh, there are two Akhils. Marisetti Akhil, one. Another one, Gajavalli Akhil. Very good. Both are correct. Midun, correct. What, Lavanya? What, same? Infinity is the answer. Why? Constant is power signal. Constant for all time power. Already in our question, yt is energy. Power signal plus energy signal means resultant power. How much energy is needed, sir, for power signal? Infinite energy. Constant for all time is power signal. For that, y of t is added, which is an energy signal. Power signal plus energy signal means power. Energy becomes infinity. Okay. Tell me, what is the energy in the symmetrical triangular pulse? If it covers from -1 to 1, sir, I want energy in this. Not area. Area is half base height, we know. I am asking energy. Energy in that signal. How much energy? Chandrika, correct. Ashish, correct. Normal enjoyment is finding this ramp expression. This is positive ramp, this is negative ramp, sir. T plus 1 minus T plus 1. So -1 to 0, T plus 1 whole square dt, one quantity. 0 to 1 minus T plus 1 whole square dt, another quantity. When you simplify, you will get the answer like 2 by 3. That is T plus 1 whole cube by 3, like that. But that is time waste. Whenever you take triangular pulse of width T having amplitude A, sir, the energy answer is A square T by 3. So for this triangle, 1 whole square, width of the triangle 2 by 3, 1 whole square into 2 by 3 for a triangular pulse. If you take half cycle sinusoid, sir, if you take half cycle sinusoid, the energy answer becomes A square T by 2. But if you take a rectangular pulse of width T having amplitude A, energy is A square T. For easy remembrance, I have written in sequence. Rectangle A square T, half cycle by 2, triangle by 3. Last problem is rectangle only. Apply A square T logic, sir. 1 whole square into 4. Answer 4. Here 1 whole square into 4 by 3. Answer 4 by 3. Energy in the rectangle is A square T logic. That will work out directly or not. These quantities will never change. These quantities will never change. There is no need to waste our time. Instead of performing that stupid integral, directly we can take a square t by 3 logic. Using these as hint, these generalized formulas as hint, now you try to answer me what is the energy in this signal, sir? I want energy in this signal. Zero to 6 it covers with a different amplitude. What is the energy in this signal? Hint also I am providing to you. This can be written as sum of a rectangle with middle for what length there is raise in the amplitude, sir? 2 to 4 there is raise in the amplitude. So you can write that as sum of rectangle and triangle. Vishal, wrong. I know most of the fellows will give that answer only. Enjoy karo. Come on, bachas. All are wrong answers. Single fellow has not given correct answer till now. Continue your emotions. Carry on. You are writing GATE exam here, not BTech. Bhanu Prakash, see it properly. Maybe it is typing error. See it properly. What you have typed. No. Venkatramana, correct. First fellow who has given correct answer, Ramana. Gayatri, correct. This fellow Ravi wants me to do that addition. Array, you do re, then you will know the answer. What, Ravi SK? Most of the fellows will take rectangle and triangle energy, but we have one more component. Energy in the signal is integral of x1t plus x2t whole square dt. One is integral x1 square t. Another one integral x2 square t. One more term 2 times area under product of the signals x1t Anyway, this is rectangular part energy. This is triangular part energy. But what is product of x1t and x2t, sir? If I draw it separately, rectangle multiplied by triangle means that triangle with amplitude here to 2 into 2, 4. So this part a square t logic, 2 whole square into 6. Triangular part a square t by 3 means 2 whole square into 2 by 3. Last one 2 times. Area under, this is the triangular pulse x1t, x2t product is triangle 2 times area. Area means half base height. Half base height. 104 by 3 is the result. The given shape is sum of rectangle and triangle. First rectangular part whole square, triangular part whole square, 2 times area under product of the signals. When rectangle and triangle are multiplied, this answer 2 extras are area under triangle half base height. Solve it 104 by 3. Most of the fellows, again, what you have missed, the 2ab term. That is the reason you have responded as 80 by 3, which is wrong. Gate exam is like IPL. Be careful. Last ball you have to hit 6 means you should hit 6 only. Otherwise, next year IPL only. Gate exam is like that. If you lose a single question, gone. Life is gone. Those who are really serious about that exam, be careful, sir. Every fellow know the concept, but you should not miss the terms. What is there, ma? What is product of rectangle and triangle? That is 2ab term. When this rectangle multiplied by triangle, what will happen? Constant multiplied by shape means shape is retained. Here amplitude 2, here amplitude 2, overall becomes 4. But 2 into area under product. Product already we have taken. What is the area under triangle? Half into base into height. Over. That is extra added. Which also is the part of energy. Okay. One theoretical question I will ask you, think of everyone. I'm going to next slide. The product of two power signals may be power signal or an energy signal are identically zero. Justify. When you want to multiply two power signals, we are saying that resultant may be power, may be energy or zero. Which is the correct and valid combination is the question, sir. Which is the valid combination? Reference for you, step function. Assume step function is reference signal. Then you can say what is possible answer. The product of two power signals may be power, energy or zero. Which is the valid combination? Is it power or energy or zero? All combinations are possible. When you multiply ut with itself, of course, we know step function is power signal. Step function multiplied by step function means again step function, that is power. Suppose we have taken another signal from -3 to infinity, sir. Constant amplitude or infinite time is power signal. Take the folded version of it. Individually, they are power signals, but the product is which signal? A rectangle from -3 to energy. How the last combination is possible means multiply ut with this one. Individually, they are power signals, but their product is what, sir? 0. All three combinations are possible because the word maybe is used. All three combinations are possible. It may be power, it may be energy, or it may be 0. Yeah. Venkatramana, you can prove for other functions. Easy example I have taken, which is understandable for every fellow. As MSQs are introduced, sir, multiple selective questions. This type of questions they can frame. Which of the following statements are true? Out of 1, 2, 3, 4, they may give 1, 2 correctly, like that. So in such cases, this type of questions are useful. Okay, I'm moving to next slide. If I take a RAM function, what is its nature, sir? RAM signal is energy, power, neither nor. RAM function is asked, is it energy, power, neither nor? What you can say? What is this function amplitude as t tends to infinity? As t tends to infinity, amplitude of the signal is tending to infinity. So without solving, we can say neither energy nor power. If you calculate either energy or power, both are infinity in the question. If you calculate either energy or power, sir, both are infinity. Similarly, suppose I have given e power -3t graph. Now you tell me, is it energy, power, neither nor? E power -3t. What is its nature, sir? Is it energy, power, neither nor? This is also neither nor. Because at plus infinity amplitude is 0, But as t tends to minus infinity, what is the amplitude of the signal, sir? At minus infinity, amplitude is tending to neither energy nor power. That is the reason we stated that point, sir. At any instant of time, amplitude is tending to infinity means neither nor. At any instant of time, amplitude is tending to infinity means neither energy nor power. Everyone, please cross-check your notes. The conclusion statements which we have made under this energy power signals are, please cross-check your notes. Go to the decaying exponential example, first example under this topic. Just I am repeating the statements which I have made. Go to the decaying exponential example. There we stated as a small t tends to plus or minus infinity, amplitude is tending to zero, so signals are energy signals, the average power is zero. Energy signal means average power zero, sir. Next statement we have made under step function. A signal which maintains constant amplitude over infinite time is power signal. Any power signal means what is energy? Any power signal means energy is infinity. Right or not? Any power signal means energy infinity. All periodic signals are power signals except continuous periodic impulse train. All periodic signals are power signals except continuous periodic impulse train. All finite length signals are finite amplitude or Wood signals. All finite length signals are finite amplitude or Wood signals are energy. Last one is this. At any instant of time, amplitude is infinity. Neither nor. At any instant of time, amplitude is infinity means neither energy nor power. All statements are equally correct. Let us verify for a discrete signal how the changes will happen. Do we have any changes or not? Only with one example, let us see the possibility. If I take a power n un, sir, for which value of a it is acting like energy means mod a less than 1. Suppose I have taken a value 1 by 3. What is the graph of 1 by 3 whole power in un means? The amplitude levels are go on decreasing. As n tends to plus or minus infinity, amplitude is tending to 0, 100% it is energy signal. Mod a less than 1 is energy. How to make the same function as power signal means mod a equals to 1, sir. Because if a is 1, it is like unit step sequence. If a value is minus 1, it is alternation of impulses. In both cases, it is maintaining constant amplitude only. 100% it is power signal in both cases. When it can act like neither nor means mod a greater than 1. Suppose we have chosen a number like 2, sir, 2 power n un. What is the graph of 2 power n un? Amplitudes are go on increasing. Of course, as n tends to infinity, amplitude tends to infinity, which is neither nor. They are equally true. The only change is continuous impulse, neither energy nor power. But discrete impulse is energy signal. Why discrete impulse is energy, sir? It is occurring at origin with amplitude 1. Finite length of finite amplitude are energy signals. Finite length of finite amplitude are energy signals. Same statements are equally true for discrete. The only difference is what, sir? The only difference is continuous impulse is neither nor, discrete impulse is energy. From these examples, you have to understand that whenever you want to say the signal as energy, power, neither nor, draw that graph and cross verify the statements which we have made. Sufficient. Whenever you want to see the nature of the signals, try to draw the graph. After that, what you have to do? After sketching the graph, cross verify our theoretical statements. Okay. I'm moving to next slide. Think of the two bits, sir. Two discrete signals are given, x1 of n and x2 of n. x1 of n is alpha into 0.5 whole power n un. Alpha is a positive real number. And x2 of an amplitude is root of 1.5 just for two samples. What is the value of alpha if the energy in the signals are equal? Already it is stated. Energy in the signals are equal. That fellow is saying Ex1 equals to Ex2. X1 of n is given as alpha into 0.5 whole power n un, alpha positive. X2 of n is defined only for two samples. It means compulsory in this question we should solve for energy, sir. Sigma mod xn whole square. Use that definition and solve for energy. Equate the answers. Tell me what is alpha. Equate the answers. Tell me what is alpha. First, we have to calculate energy in each signal. Then only we will know what is alpha. Some old students are there probably sitting in front of the camera blindly typing the answer. If I give any new question, no answer. Huh? Calculate energy in each signal and equate them, sir. You will know what is alpha. First signal is a positive side signal, so summation varies from 0 to infinity multiplied by un means positive side. Alpha square 0.5 whole square n. So alpha square sigma 0 to infinity 1 by 4 whole power n. So what is the series expansion? 1 plus 1 by 4 plus 1 by 4 whole square, etc. First term by 1 minus common ratio, that is 4 alpha square by 3 sir. Energy in the first signal. Energy in the second signal is what? It is occurring only for 2 samples. Root 1.5 whole square, root 1.5. That answer becomes 3. Summation varies from 0 to 1 sir, only for 2 samples. Ex1 equals to Ex2 means 4 alpha square by 3 is 3. Alpha square is 9 by 4. Alpha becomes 1.5. Actually, plus or minus, it is stated it is a positive real number, sir. It is a positive real number. Okay, what is given in the second bit? Think of 2 continuous signals are given as modulus of t for the interval -1 to 1, one signal. Second signal 1 minus mod t. Both signals are sampled with a sampling period of 0.25 seconds to get the discrete form of them. Then what is the relation between energy in the discrete signals? First, everyone draw continuous signals here. Later on, perform sampling. Draw the continuous signal and perform sampling. Then you will note the discrete form of that signals. X1t is given as modulus of t for the interval -1 to 1. X2t is given as both are sampled with what gap? 0.25 seconds. This is modulus of t graph, first signal graph, sir. Of course, 1 minus mod t is nothing but our symmetrical triangle. Try to sample the signal. Draw the sample form of both the signals, sir. With a 0.25 gap, 0 to 1, total 4 samples are obtained. With a 0.25 gap. Enjoy. Then you can comment on energy in the discrete signal relation. x1 of nt is nothing but modulus of n into t, sir. N is multiple of 0.25. So 0 to 1 interval, how many samples we can choose? 4. 0 to 1 with 0.25 gap. N value 0 means 0 into 0.25 magnitude is 0. N value 1, sir. 1 into 0.25. Blindly substitute here. At 2 it is becoming 0.5. At 3 it is becoming 0.75. At 4 it is becoming 1. That is x1 of nt graph. Similarly, what is sample form of this one, sir? 1 minus mod nt. If I take n value 0, 1 minus 0, 1. If I take n value 1, 1 minus 1 into 0.25, 0.75. Like that you draw. Sample form of second signal also. By looking at the graph, what you can say? Akhil, correct. There is no need to calculate energy, sir. Look at both the graphs, you will get the idea. For both the signals, 3 impulses on right and left side have same amplitude level for both the signals. 0.75, 0.5, 0.25, both sides it is there. But for the first signal, 2 impulses are having amplitude of 1, whereas for second signal, that chance is there for single impulse. For signal, we have 2 impulses of amplitude 1, whereas the chance is there for second signal only for single impulse. That indicates energy in the first signal is more than energy in the second signal. In comparison of the two graphs, we can feel that first signal energy is more than second signal energy. There is no need to calculate energy here. Just by comparison, you can say it. But continuous waveform, their energies are same or not? What is it, Nagarjuna? Idhar dekho. First signal have 3 impulses left and right side with same amplitudes. Same chance for second signal also. But for the first signal, how many impulses have amplitude of 1, sir? 2. But here that is visible only for single impulse. Means here one extra impulse with amplitude 1, automatically first signal energy dominates second signal energy. Because first signal has 2 impulses with amplitude 1. So it dominates. Okay, that is a first classification, energy and power signal, which is used to measure the size or capacity. Which is used to measure the size or capacity. Let us go to second classification, sir. Even and odd signals. Even signal and odd signal. Why this classification is needed means to observe the symmetry and anti-symmetry behavior, we are taking this classification, sir. To observe the symmetry and anti-symmetry behavior. Normally, what is even signal condition? X of t equals to x of minus t. X of t equals to x of suppose if we have taken this symmetrical triangle, our last slide only. Funny thing, last slide, both are looking like even functions are not, sir. The folded version of them is again same. If signal equals to its folded version, that is even function. What is odd signal condition? Xt equals to minus x of minus t. Here we can take an example like sine function. If you replace t as minus t, sir, it becomes minus sine of minus omega naught t means minus sine theta multiply by negative sign reproduces the same answer. But these conditions are correct for real signals. Real signal means if their amplitude is a real number, they are called as real signals. If their amplitude is real number. For complex signals, complex signal general form is A of t plus j times B of t. Then they are called as even conjugate, odd conjugate. Even conjugate shortcut I will say EC. Our branch only bachas. Xt equals to x minus t with the conjugation. Complex signal means extra what needed, sir? Conjugation symbol needed. Same conditions are same as this extra conjugation. Suppose if I take t square e power j omega t, sir, because e power j theta is there, it is complex. What is x minus t answer? Minus t whole square is t square exponential negative. What is the conjugate of that? T square into e power j omega t. Xt equals to x star of minus t. That condition is satisfied means it is even conjugate. Similarly, we can say odd conjugate behavior. Xt equals to minus x conjugate of minus t. Here we can give a example like t e power j omega t, sir. Xt equals to minus x star of minus t. So there are certain signals which can satisfy separately even behavior or odd behavior. Real signal, complex signal conditions are one and same. What is the only difference? For complex signal, placing extra conjugation. For complex signal, we are placing extra conjugation symbol. Just go through it, everyone. Just go through it, sir. Complex signal, you place extra conjugation symbol. So there are certain signals which can directly satisfy any one behavior, maybe evenness, maybe oddness. But if the signal has no apparent symmetry, if the signal is not at all satisfying any symmetry, then we are decomposing them as sum of even and odd parts. If the signal has no apparent symmetry, then we are decomposing them as even and odd parts like this. If you take a general signal xt, we can write that as xct plus x4t. Replace t as minus t in this expression. What will happen? X minus t equals to xc of minus t plus x4 of. But according to even signal definition, what is the first quantities are? X minus t stands for xt. According to odd signal definition, what is x minus t? Minus x4t. If we add both the expressions, that is giving back even part. If you do subtraction, equation 1 minus equation 2, that is giving us odd part, xt minus of x minus t by. Add the signals, amplitude divided by 2 is even part, subtraction divided by 2 is odd part. For a complex signal, what we have to place here in the formulas? Instead of x minus t, what we have to write for complex? X conjugate, x star x conjugate of minus t. I am asking a very simple question. Everyone should respond the answer in chat box. Very simple model I am giving. What are the even and odd parts of UT, unit step function? Tell me the even part and odd parts are. Very easy question. What is the even part? What is the odd part? Are funny fellows, this example also you are doing wrongly. Chi 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 chi. Are funny fellows. What is the folded version of the signals are? Even signal means add the signal amplitude divided by 2. That becomes 1 by 2. xt plus x minus t by 2, that is 1 by 2. Odd signal means which terms are added, sir? X of t added to minus x of minus t. This is x minus t. What is minus x of minus t? Like this. Amplitude divided by. That is looking like signum function or not? Even part 1 by 2, odd part half signum. Even signals are symmetrical about y-axis. Odd signals are anti-symmetrical about y-axis. Even signal means symmetrical. Odd signal means anti-symmetrical. We can verify because we already know the result. Yesterday, how we have written signum in terms of step function? What is signum in terms of step function? ut minus u minus t, one expression. Other expression, 2 into ut minus 1, from which ut is 1 plus signum by 2, sir. 1 by 2 one term, another term 1 by 2 signum. This is even part 1 by 2, odd part 1 by 2 signum. 1 by 2 is the even part, 1 by 2 signum is odd part. Funny fellows, this simple question also, why you have given wrong answer? Don't take my shoutings very seriously into your heart. To make you more emotional in the subject, I will use all those words. Bachas, like that. You are not bachas. Most of you are BTech completed. Some of them may be in the final year, probably. Okay. What is area under any odd signal, sir? What is area under any odd signal? 0. Positive area, negative area, cancellation. So area under odd signal is 0. But area under even signal becomes what? Because of its symmetrical nature. Area under even signal becomes 2 times one-sided area. Area under odd signal 0. Because of its symmetrical nature, area under even signal becomes 2 times one-sided area, sir. Odd signal means anti-symmetric, ma. Even signal means the word symmetry is used. Odd signal means anti-symmetrical or asymmetrical. What is sum of 2 even signals, sir? If you are adding 2 even signals, resultant is even. What is sum of 2 odd signals? Odd plus odd is which signal? When we try to add 2 odd signals, what is the answer? Huh? Answer is odd. We are not adding numbers, bachas. 3 plus 5 is 8. Sin t plus sin t is 2 sin t. Sum of 2 odd signals is odd. Sum of even and odd signal, neither even nor odd. See our last example. Half and half signum are added, that is giving step function which has no symmetry. Product of 2 even signals, even. Product of 2 odd signals, even. Even into odd becomes what? Odd. Be careful here, sir. Sum of 2 odd signals is odd. Sum of even and odd is general. Neither nor. Differentiation of even signal is which signal? Odd signal. We should say the word differentiation of non-constant even function. Because last problem we got 1 by 2 which is even part. Differentiation of 1 by 2 becomes 0 or not. So the correct statement is differentiation of non-constant even function is odd. That is the purpose of solving this problem specifically, sir. Differentiation of constant 0. That is the reason. Differentiation of non-constant even function is odd. Vice versa. Opposite also true. Same statement is equally correct for integration also, sir. Integration of even signal is odd signal, maybe plus extra c. If it is not a definite integral, extra plus c. These concepts again I will ask you in Fourier series and DTFT multiple times. Don't forget. That is the reason these funny things I am explaining here only, sir. Area under even signal, area under odd signal. We require it, that concept. Differentiation of non-constant even function is hard. Please think of this model. Maybe still some of you are in 36. Go through it, sir. Find the conjugate antisymmetric part of this data. Antisymmetric means even function, odd function. The word antisymmetric means odd. Arrow mark indicates sample at 0. You have an idea on that. So the index given is -1 to 1. Because they are complex numbers. What is the change in the definition, sir? Normal definition xn minus x minus n by 2 extra conjugation because they are complex numbers. Extra of minus n. Wow, what a question. How odd into odd becomes even? Let me explain. Sin t into sin t. Sin square theta is what, ma? This one. Clear? Sin and sin both are odd functions. Overall becomes even function. Just a substitution of samples to get the answer, sir. We are getting complex number means we are using MATLAB programming. Real time, all real world signals are maintaining real amplitude only. So just substitute each index. 1 plus j2 minus conjugate of x1 means minus j5 by 2. At 0 it is 0, sir, because it is a real number. 2 minus 2 by 2. N equals to 1 some number. Last sample you solve some result. X1 minus x conjugate of minus 1 by 2. Don't forget to take that conjugation. Complex signal means compulsory that star. X star of minus n is needed. Very good, Kiran Kumar. You have typed the answer also. Enlak sir, name is Kiran Kumar. Both of us are very thickest friends. One theoretical question I'll ask you, respond. Theoretical question. If x EC of n represents even conjugate part of xn, what type of symmetry? Its real and imaginary parts exhibits. I have given the word even conjugate part of xn means maybe signal is complex. That is an indirect indication. So complex signal can be written as real component plus j times imaginary component. If x EC of n represents the even conjugate of part of xn, what type of symmetry its real and imaginary parts exhibits? Think of and answer me. What is x EC of n definition? Every fellow knows. Even conjugate part definition is what, sir? Normal real signal means xn plus x minus n by 2. Complex means extra conjugation. So what is the conjugate of this term, sir? xrn minus j times xi of n. Just substitute here. xrn plus j times xin plus what is x star of minus n meaning, sir? Already x star n available. xr of minus n minus j xi of. Separate out its real part and imaginary. xrn plus xr of minus n by 2 j times xi of n minus xi of minus n by first bracket term is the real part looking like even definition. Second bracket term is imaginary part looking like odd definition. That is what my question. Real part exhibits with symmetry. Imaginary part exhibits with symmetry. Real part is even, imaginary part odd, sir. To play with you for gate examiner, in-depth questions are not required, sir. Suppose this question is asked. What is ABCD option? Both real and imaginary parts have even symmetry, or one is even, the other one odd. Both have odd symmetry. Even they frame theoretical question, mathematically only we can understand it. First we have to understand it is a complex signal A plus JB, take conjugation. After substitution we decided first bracket term even part, second bracket term odd part. So real part has even symmetry, imaginary part has odd symmetry. Suppose the question is opposite. If I ask the same question for odd conjugate part of xn, what do you have to say? If I ask the same question for odd conjugate part of x of n, sir, then what will happen? Come on, come on. If I ask the same question for odd conjugate part, what will happen? Then real part will be odd, imaginary part will be even. Real part will be odd, imaginary part will be even. Correct or not? Okay. The next classification which we are discussing here is causality. Causal and non-causal signal. Write the spelling properly. CAUSAL. Don't write casual. Causality. CAUSAL. What is definition of causality is if any signal is defined for positive time, then it is causal function, sir. If any signal is defined for positive time, then it is causal. Indirectly, what is the amplitude of that signal for negative time, sir? What is the amplitude of that signal for negative time? 0. If any signal is defined only for positive time, then it is causal. If any signal is defined only for positive time, then it is causal. Suppose if you have taken u of t minus 5, where the signal covers 5 to infinity, only positive time causal, 5 to infinity. If I have given u minus t minus 5, sir, that covers now purely negative time. Opposite to causality known as anti-causal. Purely negative time is anti-causal. If a signal is two-sided, which exists before 0, after 0, then it is non-causal. Purely positive time causality, purely negative time is anti-causality. A signal which is two-sided before 0, after 0 is non-causal function. Yesterday, we studied the word real-time, non-real-time, hybrid. Which are the real-time signals means? Causal signals are real-time signals. Which are the real signal means? Causal signals are real-time signals. Here you must be careful with a word right-sided signal. Right side signal means wherever it starts, from that instant to right side. If I am starting the signal at -2, after -2 it covers. If I start at 3, sir, after 3 it covers. From the instant to right side is called as right side signal. Can you say right-sided signals are causal, sir? Can you say right-side signals are causal? Need not be. That is false. But all causal signals are right side or not. Every causal signal is right-sided. But a right-sided signal need not be causal. Similarly, you can think of left-sided signal. It may start anywhere, but it is ending at a particular instant. These funny questions are asked in engineering services papers are right side definition, left side definition, like that. Okay, be careful. All causal signals are right side, 100% correct. A right-sided signal need not be causal. So causality, right-sidedness are not interchangeable words. Similarly, anti-causality, left-sidedness, they are not interchangeable. Today we have made 3 statements on this concept. Inverse of interpolation is decimation. Reverse way, it need not be true. Reverse. All periodic signals are power signals. Reverse way need not be true. Reverse. This is one more. All causal signals are right-sided. Right-sided signal need not be causal. What is the significance of causality of a signal? You will know once I start convolution chapter. Till that time, remember the definition. Till that time, remember the definition, sir. Okay. Take a short break. Again, we'll start the periodicity concept. There is another lengthy topic we are learning. Periodic, non-periodic function. Within 20 minutes, have a cup of tea and come back, sir. 20 minutes. Okay, let us continue. Continue our discussion. Causality definition we observed as a signal that is defined for positive time is considered to be causal function. The next classification which we are learning is periodic and a non-periodic signal, which is also called as aperiodic. Periodic and non-periodic, which is also called as aperiodic signal. If a segment is repeated continuously for infinite length, then we can say signal is periodic. If a pattern is gone repeating continuously for infinite length, then we can say the signal is periodic signal. What is the advantage of taking this concept is we are measuring the harmonics. If omega naught is the fundamental frequency, n omega naught indicates nth harmonic of fundamental frequency. Whether signal repeats for integer cycles or non-integer cycles, that is what we are calling as harmonics. Generally, if the signal repeats for integer cycles, then it is periodic function. If it is non-integer value of omega naught, then it is non-periodic function. Because of which we are learning two topics, Fourier series and Fourier transform. Fourier series strictly for periodic functions. Fourier transform is taken for both periodic and non-periodic function. Any signal can be taken as combination of harmonics. Periodic signals by harmonics at integer frequencies, non-periodic signals at non-integer frequencies. Non-integer harmonic frequencies means non-periodic signal Fourier transform. Integer value of fundamental frequency means periodic signal, that is Fourier series. So, what is the time domain condition for periodicity is x of t must be equals to x of t plus or minus m into t naught, where t naught is the least time period of x of t. M is a integer value 1, 2, 3, etc. M is a integer value. See, sir, suppose we selected a sawtooth wave pattern like this. It is repeating the pattern for every 2 seconds. So the least period of the signal is 2 seconds. Same segment is go on repeating continuously for infinite length. Same segment is go on repeating. This is a compulsory condition for every periodic waveform except DC, sir. This is a compulsory condition for every periodic waveform except DC. Because when you add extra DC to a periodic function, suppose we have taken 1 plus cos pi t, what will happen, sir? There may be raise in its amplitude level, but still it is not affecting the repetition of the pattern. It is not affecting the repetition of the pattern. It remains same. Okay? So it is a compulsory condition for every periodic waveform except DC. That is the reason in Fourier series we are always adding extra A naught DC value. Extra A naught we are adding. What is that periodic signal that we are using in our daily life, sir? What is that periodic function that we are using in our daily life? Which periodic signal? Electricity, which is represented in terms of sine and cos function. Electricity. Our voice signal also. Voice signal is treated as quasi-periodic waveform. Quasi-periodic means semi-periodic. Initial time it will look like periodic, and certain intervals it is non-periodic also. See, if you see the graph, initially it is non-periodic. After some time we feel repetition of the segment. After some time we feel repetition of the segment. Actually, for each fellow we have some fundamental frequency that is called as pitch, the perceived frequency. For men it is in the range 250 Hz. Women 400. Children will have 500 Hz. Whatever the other frequencies of utterance are there, they are always depending on this fundamental component. They are always depending on this fundamental component. That is what quasi-periodic means. Om Sri. 100% you will not get the same thing. Quasi-periodic. Okay. There we are using a word in voice called as formant. We are not using the word harmonic frequency, formants. There is a different story. Choddo. Suppose we uttered the letter and observed the frequency to be 1000 Hz. In the process of uttering that letter, how many cycles we have chosen, sir? 4 cycles, because our basic number is 250. See, when you are a child, what is our range? 500 Hz. As the time progresses, we will come to this number 250. Every musician will use the concept of periodicity, sir. When you are playing violin or guitar strings, these symbols, I think you have observed, they are called as notes. Based on the quality of these musical notes, we are getting that respective song. Whenever you are listening to a particular song, whatever the initial music pattern that is played, somewhere in the middle of the song, they are repeating the pattern. Even at the end of the song also, they are using starting pattern. That is what quasi-periodic. For all the time, they are not playing the same music, sir. Suppose the song is played for 5 minutes. For first 15 seconds, again middle of the song 15 seconds, maybe end of the song last 15 seconds, there is repetition of that pattern. Of course, there are some exceptions for that. In Telugu, we have our Taman Bhaiya. He's a exceptional fellow. Irrespective of the movie, music will be same. So that fellow knows how to use periodicity thoroughly. Don't feel bad if any diehard fan is there of Taman. Easy example I am saying. So what for we are learning this concept means, we are checking that whether the signal repeats for integer cycles or non-integer cycles. If it is repeated for integer cycles, periodic. Non-integer cycles means aperiodic. Okay. So finally, after learning this concept, what is the main point we are checking, sir? Whether the signal repeats for harmonics or not. If I say 3 into omega naught, it means which harmonic? Third harmonic, 3 cycles, the pattern repeats. Whether the signal repeats for integer cycles or not, that point we are checking. Okay. See, if it is a single signal, by looking at the graph only, you can say whether it is periodic or aperiodic, sir. If it is only one signal. Suppose we are adding multiple signals, x1t plus x2t plus x3t. When multiple signals are added, how to check whether overall signal is periodic or aperiodic? For that, we are following a procedure. So I'm going to next slide. When multiple signals are added, how to check whether the added signal is periodic or aperiodic? We are following a procedure for that. So procedure to find time period of sum of signals x1t plus x2t plus x3t. When number of signals are added, how to check whether the added signal is periodic or aperiodic? It is a regular model in the exam, sir. Periodicity concept also regular model. First step here is identify the individual time periods. We are denoting first signal period as T1, second signal period as T2, like that symbols. Identify the individual time periods, first step. Second step is calculate T1 by T2, T1 by T3, T1 by T4, etc. We are calculating all ratios with respect to the first period. What is the reason we are calculating all ratios with first period means whatever the other frequencies we have, they will depend on fundamentals. We are getting 5 into omega naught means omega naught reference. We are getting 11 into omega naught means again omega naught is reference. Try to calculate all ratios with respect to first period. Third step, if the ratios of second step is a rational number, then the overall signal is periodic. If you calculate the ratios, if you got that as a rational number, then automatically the added signal is periodic. What is the meaning of rational number? Suppose we got 3 by 5 and 2 by 3. They are valid rational numbers. They are valid rational numbers. If you got the answer like 2 pi by 3, sir, it is irrational. Integer by integer form. Integer by integer form. Fourth step, calculate LCM of denominators of step 2. Least common multiple. LCM means least common multiple. Suppose this case, what is the LCM of 5 and 3, sir? 15 we have to take. LCM of denominators of step 2 means LCM of 5 and 3, 15. If we have only one ratio, take the denominator itself. Only one ratio is there means we added two signals only. Only one ratio is there means we added two signals only. Last step, capital T is LCM times the first period. The overall period of the signal is LCM times first period. So when we are using this procedure, sir, whenever two or signals are added, to check whether the combined signal is periodic or aperiodic, follow this process. Whenever two or more signals are added. First, everyone go through the last slide. What is a simple way of defining a periodic signal? If a pattern or segment repeats continuously for infinite length, then it is periodic. If a pattern or segment repeats continuously for infinite length, then it is periodic. When you have a single signal, just by looking at the graph, we will say whether it is periodic or aperiodic. But when multiple signals are added, sir, we should follow this procedure. Procedure to find time period of sum of signals is this technique. First step, calculate the individual periods. Second step, all ratios with first period. Third step, if the ratios of step 2 is a rational number, then overall signal is periodic. Then LCM of denominators of step 2. Finally, overall period is LCM times the first period. LCM times the first period, sir. Please take a snapshot such that we can solve few examples on this concept, sir. Please take one snapshot. Let us discuss few examples here. Suppose We are adding two sinusoids like this, sir. Cos 12 pi t plus sin 18 pi t. Cos 12 pi t plus sin 18 pi t. Check whether the signal is periodic or aperiodic. We have two frequencies, 12 pi, 18 pi. In general, omega expansion is 2 pi f. F is 1 by t. F is 1 by t. So think of whether the added signal is periodic or not. Think of, sir. The two frequencies now in the example are 12 pi, 18 pi. Omega expansion is 2 pi f. F is 1 by t. So T1 becomes 1 by 6. Here 2 pi by T2 is 18 pi. T2 becomes 1 by 9. First step is that identify the individual time periods. Second step is the ratio T1 by T2. 1 by 6 by 1 by 9, 3 by 2. Blindly follow the procedure, sir. Blindly follow the procedure. Of course, third step is valid. Ratio must be rational. We got 3 by 2 rational number. Fourth step is LCM of denominators. There exists only one ratio. What is the denominator, sir? 2. Last step is LCM times T1. One by 3. Both the signals are individually periodic. Even the added signal is also periodic with the change in time period as 1 by 3. They are individually periodic, sir. The added signal is also periodic. Actually, the point you should understand is to make 1 by 6 as 1 by 3, what is the multiplier we need, sir? To make 1 by 6 as 1 by 3, what is the multiplier we need? 2. Similarly, 1 by 9 as 1 by 3, what is the multiplier we need? 3. First signal has to repeat 2 cycles. First signal has to repeat 2 cycles. And the second signal has to repeat 3 cycles such that it is forming a new period as 1 by 3. Roughly, cos waveform is like this. First time we got time period as how much, sir? 1 by 6. Sine waveform is like this with the time period of 1 by 9. We have added the signals. After doing addition, suppose it has formed a new graph like this. Suppose. Still the repetition occurs, but what is the change in the time period, sir? Time period becomes 1 by 3. When you physically generate, then only you will understand it. For that only MATLAB programming or LabVIEW softwares are needed. 2 cycles of first signals, 3 cycles of second signal are added to form the new time period as 1 by 3. To form the new time period as 1 by 3. The direct way of taking this answer without 5-step procedure, alternative technique is, what are the 2 frequencies we have, sir, in the problem? What are the 2 frequencies we have? 12 pi, 18 pi. Check GCD of the given frequencies. What is the GCD of them? Greatest common divisor. What is the GCD of 12 pi and 18 pi, sir? 2 into 6 pi, 3 into 6 pi. GCD of the given frequencies means 2 into 6 pi, 3 into 6 pi. Omega naught 6 pi means what is the time period? Omega naught 6 pi means what is the time period, sir? 1 by 3. Instead of 5-step procedure, by direct observation also we got same answer or not? Simply take GCD of given frequencies. What is the GCD of 12 pi and 18 pi? 2 into 6 pi, 3 into 6 pi. Time period becomes 1 by 3. You can follow that 5-step procedure or direct method. With respect to time period, our concept LCM. With respect to frequency, our concept GCD, sir. Whichever you like, follow that method. Time period means LCM concept, frequency means GCD concept. Okay, I'm going to next slide. Now you think of and respond. Cos pi t by 5 plus sin pi t. If it is periodic, what is the fundamental period, sir? If it is periodic, what is the fundamental period? Cos pi t by 5 plus sin pi t. Correct, Ashish. The two frequencies visible are pi by 5 and pi. Second one can be adjusted as 5 pi by 5, sir. So omega naught is GCD of pi by 5 and pi. Of course, answer is pi by 5. Time period becomes 2 pi by omega naught, 10 seconds. Pi by 5 means first harmonic fundamental. Pi means fifth harmonic in this question. GCD of pi by 5 and pi. Simply take GCD, which is direct technique. Suppose sum of two complex sinusoids is given. Then you think of e power j 5 pi t by 3 plus e power minus j pi t by 6. We stated complex sinusoids are periodic functions. E power plus or minus j omega naught t, they are periodic. Sum of two complex sinusoids are given, sir. Whether they are periodic or aperiodic, decide and tell me. If periodic, what is the fundamental period? Very good. 12 is the answer. In the exponential power, what are the frequencies visible, sir? 5 pi by 3, pi by 6. The first frequency can be adjusted as 10 pi by 6. So omega naught is simply GCD of 5 pi by 3, pi by 6. That can be directly pi by 6. Time period becomes 2 pi by omega naught, 12 seconds. Simply go for GCD concept. If it is given as this way, sir, sine into cos. First, we have to convert multiplication to addition. First, we have to convert multiplication to addition. Then only we can say it. Carry on. Tell me whether it is periodic or aperiodic. Two sin A cos B rule. 1 by 2 times 2 sin A cos B. So do that adjustment. Sin A plus B plus sin A minus B. Sin of A plus B plus sin of A minus B. So after simplification, what is the first frequency? 22 pi by 15. Second time, you get negative sign. Sin minus theta is minus sin theta. So what are the two frequencies visible, sir? 22 pi by 15 and 2 pi by, what is the GCD? 11 into 2 pi by 15, 1 into 2 pi by 15. N omega not logic. So time period becomes what, sir? 15 seconds. First convert multiplication to addition, 2 sin A cos B rule. Arey bachas, we have to go for greatest common divisor or not? Take GCD. Try to convert multiplication to addition. Then you can answer, sir. Okay. Suppose I have given sum of three sinusoids like this. Now you tell me 2 sin 2t by 3 plus 4 cos t by 2 plus 2 cos t by 3. Sum of four sinusoids, sir. Simply, if you are using our direct concept, what are the three frequencies visible, sir? 2 by 3, 1 by 2, 1 by 3. We are expecting GCD of them. For 3 and 2, what is the common multiplier, sir? 3 2s are 6. Common multiplier is 6. So 2 by 3 can be adjusted as 4 by 6. 1 by 2 can be adjusted as 3 by 6. 1 by 3 is adjusted as. So which harmonics we have? Fourth, third, second harmonic. 3 2s are 6. First I adjusted that multiplier. 2 by 3 is 4 by 6. 1 by 2 is 3 by 6. Like that. So time period is 2 pi by omega naught 12 pi. 2 pi by omega naught 12 pi. So now you think of sin 13d plus cos 15 pi t. Periodic or aperiodic? Without solving, we can say non-periodic. Very good. Because we cannot take GCD. 13 and 15 pi GCD is not possible. Both signals are individually periodic, sir. First time 2 pi by 13. Next time 2 by 15. They are individually periodic. But the ratio T1 by T2 jump, it becomes an irrational number. Irrational number. Non-periodic. What, ma Meghana? You may get a doubt when you are deciding the answer by simple GCD concept. Why you have provided that 5-step procedure? Why I have given that 5-step procedure is, suppose assume we have added 3 periodic signals where their time periods are given like this: 1.08 seconds, 3.6 and 2.205. Asked for what is the combined period of the signal. 3 signals are periodic, their fundamental periods are also mentioned. Can you say the answer now by GCD concept easily, sir? Can you say the answer easily by GCD? Not possible. We have to check T1 by T2, T1 by T3, that style only. Luckily, all the models which we observed are based on n into omega naught logic, simple logic. If the time periods are like this, we have to follow blindly that 5-step procedure or not. For this type of problems, you should apply it. Let us take single signals. We have done sum of signals now. Let us take single signals. Suppose this is given, sir, xt j into e power j 10t. Is it periodic or aperiodic? A complex sinusoid extra multiplied by j. A complex sinusoid extra multiplied by j. Is it periodic or aperiodic? This extra j represents additional phase angle that is introduced. So it is like e power j omega naught t plus theta forms. Phase angle is decided by omega naught, not by theta. Phase angle is decided only by omega naught, not by theta. Omega naught is 10. So time period becomes 2 pi by omega naught. That is pi by 5. Verify whether this answer is correct or wrong. X of t plus t naught must be equals to xt, sir. So j times e power j 10, t is replaced as t plus pi by 5. So j times e power j 10t, another answer e power j 2 pi. Of course, e power j 2 pi is 1. We have recovered our original signal. E power j 2 pi is 1. We have recovered our original signal, periodic. Before exponential, that extra j multiplier represents additional phase angle that is not at all affecting the periodicity. That is not at all affecting periodicity. Periodicity is decided by omega naught, not by theta, sir. Periodicity is decided by omega naught, not by theta. This e power j 2 pi means answer 1 cos 2 pi plus j sin 2 pi. Now you think of e power minus 3 plus j 5 into t. Periodic or aperiodic, sir? E power minus 3 plus j 5 into t. Is it periodic or aperiodic? Huh? Very good. Non-periodic. What is the reason? Because of e power minus 3t. We know it is a real decaying exponential with no repetition of the pattern. There is no repetition of the pattern. Non-periodic. Understand the difference carefully. Previous example is complex sinusoid, that is periodic. This is complex exponential. It cannot be periodic unless sigma 0. Yesterday we have written that as sigma plus j omega, sir. Complex exponential cannot be periodic unless sigma is 0. This one, sir, sin pi t by 4 ut. Periodic or aperiodic? Sin pi t by 4 ut. Is it periodic or aperiodic? No. Non-periodic because it is switched sine wave. Switched sine wave starting from 0. All periodic signals are everlasting signals. In the time domain, we have to cover from minus infinity to plus infinity. All periodic signals are everlasting signals. They should cover from minus infinity to plus infinity. This is a switched sine wave existing for positive interval, directly non-periodic. Latest gate paper. What is asked for instrumentation, bachas? Sine of square root of 2 pi t. Periodic or aperiodic? Sine of square root of 2 pi t. Is it periodic or non-periodic, sir? Non-periodic function. Because if t is negative, suppose I want instant -2, root of -2. What is sine of imaginary, bacha? Meaningless. Non-periodic. If the same function is given like this, sir, sine of root 2 pi into t, no problem. Sine omega naught t form periodic. But t is there inside the square root, that is non-periodic. T is there inside the square root. Think of this. Even part of cos 3 pi t ut. EV stands for even part. Even part of cos 3 pi t ut. Periodic or aperiodic, sir? Signal subject always follow this logic. If you are unable to understand the given mathematical expression, immediately draw the graph. That is one technique. If you are failing in time domain, go to time domain, back to time domain. Suppose you have not understood this expression, sir. Try its graph. Cos 3 pi t ut like this. We want even part means take its folded version, amplitude divided by 2. So when you look at the graph, definitely pattern repetition is there. Definitely pattern repetition is there, periodic. If you want to know exact answer, simplify, sir. What is even signal definition? Signal plus folded version by 2. Cos minus theta is cos theta. Take cos 3 pi t common, ut plus u minus t by, anyway bracket term is 1, sir. 1 by 2 cos 3 pi t. It is a single sinusoid having time period as 2 by 3. Even part of cos function is cos itself. Even part of cos function is cos itself, periodic. Follow blindly the classic. Graph to mathematical expression to graph. Time domain you are failing means go to transform. Transform domain you are failing means come back to time domain. Suppose same problem instead of cos. If I give sin, sir, think of same problem instead of cos. If I have given sin, even part of sin 3 pi t ut, then you think of periodic or aperiodic. Sin is a even function or odd function? Odd function. If I try to draw the graph here, what will happen? Sin 3 pi t ut like this. Even part means take its folded version. Amplitude divided by 2. No repetition because of this segment. No repetition visible. So non-periodic. Everyone respond in the chat box. What about this summation? Sigma minus infinity to infinity minus 1 whole power k del of t minus 3k. Del t means continuous impulse. Is it periodic or aperiodic? Sigma minus infinity to infinity minus 1 whole power k del of t minus 3k. If you are unable to decide directly, draw its graph. Expand the summation and try the graph, sir. For all positive k, it is plus 1. For all even k, even index of k, it is plus 1. Odd index, it is minus 1. Try to draw the graph by expanding the summation. Etc. K place minus 1 means minus del of t plus 3. K place minus 1. K0 del t. K1 minus del of t minus 3 like that, sir. For all even index of k plus 1, odd index minus 1. So it is alternating impulses. We feel that repetition for every 6 seconds. We have alternation of impulses for every 6 seconds, sir. It is alternation of impulses. Periodic. We have seen continuous signals examples on periodicity. The three standard forms of periodic functions are cos omega naught t, sin omega naught t, as well as e power plus or minus j omega naught t. Three forms are, one is cos, the other one sin, the other one e power plus or minus j omega naught t. They are always periodic separately. Once we add them, we have to follow GCD concept. Discrete, I will discuss in tomorrow's class. On today's discussion, some homework models for you on today's discussion. Okay. G of n is u of n plus 3 minus u of n minus 5 if h of n is g of 3n. What is sum of all values of hn? Every fellow knows un means unit step sequence. U of n plus 3 minus u of n minus 5 is the given signal. Then we decimated it. What is sum of all values of hn? A discrete signal is given like this. Try to sketch these two signals. A discrete signal is given as 1 minus mod n by 3. Try to sketch these two signals. Last one. Find out the energy in the following signals. A rect t plus B rect t minus 0.5. What is the energy in that? Another signal. We want energy in these two signals, sir. You can apply sum of rectangle and triangle concept here. Rectity means every fellow knows where it covers. Rectity means minus half to half. Both are finite length signals means 100% their energy. Think no emotions. Just for practice, I have given these three examples. If you show real interest, at the end of every class, I'll give some problems, sir, for practice. Still, periodicity of discrete signals we have to discuss. We completed only for continuous today. Still, we have to discuss periodicity of discrete signals, sir. These three signals you try. Three examples. Regarding my contact number, this is my mail ID. My name only. This is my number. If you have any clarification in the subject, you can contact me after 1 o'clock any day. After 1 o'clock. Don't send assignments to me. Please solve the following problems. I will not do it. Okay. Conceptually, if you have any clarification, you can contact me. I will clarify, sir. Don't send assignments to me. Sir, what happened to positive RAM, negative RAM? Don't do that overaction. Only explanation I will do. Some fellows, they will send 10 to 15 problems to me. I am not a student to do all those things again. It is your job. Problem clarification means once you contact me, you will get it. Om Sri, just now I am mentioning now, again why you are asking. If it is 1 or 2 questions, generally I don't have that much time to observe WhatsApp or anything. Better you contact me, you will get clarification regarding any problem. Still, if some clarification is needed, then you can send that question to me. Okay. That's all for today. Happy Sunday to everyone. Enjoy afternoon session. Tomorrow evening, only 2 hour session, 5 to 7. I am taking only 2 hours. That's all for today. Yes, ma, tell me. Speak out, Om Sri.
Good evening, sir. Sir, good afternoon, sir. Sir,
Okay, no
this
problem.
del of T, you said like it is neither energy nor power signal, right, sir?
Yes.
Sir, but in starting we consider this del of T, I mean this impulse function as a triangle onlyness. I mean, sorry, as a rectangle onlyness. Sir.
All physical signals are finite length signals. That is only our feeling. Even Gaussian function is also infinite length. Na? That is also approximated as impulse. That is only our feeling.
Okay, sir.
It is used for mathematical analysis. Practical form of impulse, we are taking discrete impulse because it is maintaining finite amplitude. Mathematical analysis is done by continuous impulse. There, in the explanation, we use a rectangle that is finite length, but immediately I use Gaussian also. It is not finite length. So there are so many signals that can be approximated to that shape. Okay?
Yes, sir. Yes, sir.
Right.
Yes, sir. Thank you, sir.
Hello, sir. Sir,
Telma.
sir, 15F slide.
15F. Almost we are in 50th slide. Wait. Telma.
Sir, in this problem, I didn't get that how the final waveform is coming, sir. Can you please explain it once?
What is the expression given? 1 minus sigma term. 1 means 1 for all index.
Yes, sir.
Summation after expansion, I have impulses from 4 to infinity. Subtract.
Yes, sir.
After subtraction, 4 to infinity, same amplitude means it is 0. Signal will stop at 3 or not?
Yes, sir. Yes, sir.
Question में क्या पूछा? How to write this expression in terms of UN? We know our standard signal UN covers positive index, but this signal covers negative index.
Yes, sir.
UN is becoming U minus n means which property ma? Which transformation? Reversal. So first I have to take U minus n. Till 0 it is U minus n. Then I have to shift right by 3 samples to get this graph. U minus n shifted by 3 samples. So by comparison we know what is M and N naught. Over.
Okay, sir. Okay. Okay, sir. Thank
Right.
you. Yes, sir.
Sir, page number 43F, sir.
क्या हो गया?
Sir, here why, how you are deciding this exponential, sir, e to the power? How you are deciding that this is periodic signal because you are calculating GCD?
E पर j theta expand करो क्या होता है?
Cos theta plus j sin theta.
Cos theta sin theta are periodic है periodic?
Periodic, sir, periodic.
Over e power j theta also periodic only.
And next problem, sir, next to this 44F. Here how also not, sir, this not e power j5 pi t by 3.
Cool. हाँ इधर देखो. यही है ना?
No, sir, that one that we got 12 second as answer.
Which one you want? E power?
j5 pi t by 3.
That is this only. Bacha, I am showing here only, na?
Yeah. This one, sir.
This
Yeah. Understood, sir. This one like also e power j theta.
Okay. You are asking me question, you know the answer. Okay. Telma, Aisha.
Yeah, sir, my doubt is regarding yesterday's question, like evaluation of the following integrals. So one of the question in book list was related to del of t minus 5 integrated.
That is delta dash of t minus 5. Wait karo, doublet. Tomorrow's class you will know. Doublet still not discussed.
Yes, sir.
Derivative of impulse is called as doublet. Tomorrow I will discuss it.
Okay, sir. Okay, that's
right.
Okay,
Right.
Thank you, sir.
Sir, in 25F.
Hmm.
Sir, here, how you are considered as a power signal, sir? It
A
was
square by 2 is not a finite quantity.
sir, A is tending to 0 now, sir, here.
A is tending to 0. Amma,
Okay, sir, sorry, sir.
namaskar. A is
Sorry,
finite
sir.
amplitude, ma. Here extra t will get cancellation that will make a square by 2.
Oh, okay, sir.
Right, ma.
Hello, sir.
Anurag,
Page number 6, sir.
1 minute.
Sir, this right side, this waveform, sir, amplitude
This
plus 2 r of t minus 2, sir. Here, why we are not taking minus 2 r of
Listen. Before 2, what is its slope, ma? -1. Huh? But after 2, its slope changes to 1. From -1 to 1, if you want to jump, how many jumps you have to make? You are at -1.
Okay,
You are
sir.
here at -1. You want to go to 1. So you have to jump by how many units?
2 units.
2 units jump. Then only it will come now. So slope change it to 2.
Okay,
But
sir.
2 to 4, we have slope of 1. To cancel that, at 4, introduce negative ramp of opposite slope minus r of t minus 2. Over.
Okay, sir.
Right.
That means here we don't get this 2 amplitude, sir. Minus 2 r of t minus 4.
If you cannot simply write r of t minus 2, ma, because before 2, its slope is -1. After 2, you are expecting 1. What is the change in slope? -1 becomes 1 means how much you have to add to make overall change in slope? Plus 2 you have to add. That is the reason 2 into r of t minus 2.
Okay, sir.
No, Chakrabarti. Only Monday. Tomorrow I have a work. Mondays I may take only for 2 hours. I have some other works to do. Rest of the day, 3.5 hours. Roughly I will take. Only for tomorrow. Okay, first let me save the file. Okay, bye. I'm leaving.